Hello guys, very good morning everyone. Welcome to the session and welcome to the GATE Electronics and Communication Engineering mock test. Yes, it's now less than 2 months left for your GATE examination. The electronics examination, you know, is on 5th of February and less than 2 months left. It's the high time to increase up the frequency of mock test. I believe many of you might already be giving these mock tests, but yes, here we are live to bring you a live mock test exactly as per the GATE pattern, containing all variety of questions, having the same marks distribution. All right guys, and sorry for a slight delay, we're just around 5 to 6 minutes late, but yeah, we shall now begin up and start the discussions. Very good morning everyone. Hope you're all geared up, hope you're all ready for this mock test, and without wasting any more further time, let us get started. And before we start up, share the session to all of your friends preparing for the GATE 23, because it's like now or never. Right now, you can't now think that whether I should appear for mock or whether I should delay it. No, you have to appear for the mocks now without waiting for the delay. And sometimes live mocks are like, you know, just like a mood changer. That also will be there, Raghavendra, don't worry. So these are like, you know, rather than you keep giving the computer based exam, this is just one live mock test you keep attending. What you have to do for the mock test, I'll just update you. Let's get started. Well, let's get started directly. Let's not focus on the introduction part. But yeah, one important part, let me tell you, is that if you want to prepare for GATE by the India's best faculty team and you need the financial assistance, yes, the BYJU'S Exam Prep brings you a scholarship test which can make you avail up to 90% scholarship, and this test is 10th of December. That is just today. Yes, today at 8 p.m. Saturday 8 p.m. we have the scholarship test on the BYJU'S Exam Prep. Register and get the benefits of this test. Now let's know some important points about this particular test, guys. You're going to get the exact GATE pattern. This is going to follow the exact GATE pattern. Number 1 point to be noted is the questions will be 10 from GA. The questions will be 10 from the GA part. Okay, and of course 5 1 marker, 5 2 marker. Remaining 55 questions of electronics and communication engineering, including the engineering maths. Okay, that will be 25 1 marker question, 32 marker question, and that makes it 85 of the EC, 15 of the general aptitude. You will be getting the questions of all variety, MCQ, NAT and MSQ types in this particular paper. Also, you're just required to keep a pen and notebook ready with you so that whenever you see a question on screen, you quickly start solving it. But please use only virtual calculator. No point of appearing in mocks, no point of preparing any further if still you are not using the virtual calculator. So please do it only using virtual calculator. Time lagega, lagne do. Doesn't matter. Let it take time right now, but not in the GATE examination. You'll be so habitual up to the GATE examination, right? So please only use the virtual calculator. Okay, and please keep a track of your marks. Okay, because you know, whatever questions, see, many students might be looking into mock. Some of you might be live right now, some of you may look into it later as well, but whatever question we finish here, just keep a track of your marks in a sheet of paper. Every question I have specified, whether it is a 1 mark question or a 2 mark question. Okay, and you know, for MCQ there is negative mark of 1/3. Okay, that is -1/3 for 1 mark, -2/3 for 2 marks. For MSQ and NAT, you know, there is no negative marking. So accordingly, whatever is the question, I have specified the type of the question and the marks of the question. You just start, right? Okay, and keep track of marks of how much is the marks obtained by you. However is the marks that is obtained from you, right? So guys, let's get now started. With this. I hope you're all ready for the first question coming on your screen. Here it is, and let's start with aptitude and then move towards technical in section, so that in the beginning you have the 10 questions of aptitude done with you. Okay, and this may, if you're really good at aptitude, this may give you a momentum as well. This may give you a particular momentum as well. Wait, what is the issue? Just a second. Yes, guys. Okay, so let's get started with the first question. Here it is on your screen. All right. The first 10 questions general aptitude, then we'll be starting with technical as well. Let's do it up quickly, guys. Very, very good morning all. Very, 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 very good morning. Keep joining and keep enjoying. Okay. A pipe can empty a tank in 40 minutes. A second pipe with the diameter twice as much as that of the first is also attached with the tank to empty it. There are two pipes to empty it. Okay. How much time will the two pipes together take to empty the tank? Okay. To empty that. There's only one task, empty. So there is no negative work concept here. Negative work comes when somebody is filling and somebody is emptying it. Okay. So there is no negative work concept. The only work is to empty a tank. Okay. There is a pipe which can do it in 40 minutes, but there is a second pipe with diameter twice. Okay, so guys, think about this. Only one logic in the question, that how much is the time taken by the second pipe to empty the tank, Okay, diameter is twice. This is the important word, right? So the time taken is not dependent only on diameter. The time taken is not dependent only on the diameter. It will be dependent on the cross section. Okay, let's say this is the pipe. How much water can it empty? It depends on the cross sectional area. So dear, agar diameter ko twice kiya hai, think and give me the answer. Okay, Deepto and Govind has the answer. So if the diameter is twice, what is the time? Right. Yeah, what is the area? I can say the cross sectional area is 4 times, right? So time taken will be reduced by 1. It will flow 4 times of the water as compared to first. So the time taken can be the 40 divided by 4, and that is equal to the 10 minutes. Now guys, we all know two bodies working together. What is the time taken? Simple question. Two bodies working together, xy upon x plus y. Okay, so it is gonna be 40 multiplied by that value. Okay, that is given by 10 is divided by the 40 plus 10. So that is simply 400 is divided by 50. 40 by 5, 8 minutes is your answer. A. These are all the tricks we know. If two bodies working together, the simplest case of time and work, if two bodies working together, then the answer is given by the 8 minutes, right? All right, everybody. So now let's gear up for the question number 2 here for the mock test. Here it is. Study the following information and answer questions given below. Answer the questions given below. A blood relation, 1 mark. MSQ now guys from general aptitude, mostly we expect the MCQ question normally. Okay, MCQ questions, but sometimes previously sometimes they have put NAT question and they have not specified that aptitude is only going to be MCQ. Again I repeat, mostly aptitude will be MCQ, but let's get prepared. Kya pata MSQ de diya, NAT de diya. What is the harm in preparing? So this is one MSQ question. Ultimately it's one solution, it's converted to MSQ. It's not like going to be very lengthy. Okay, so let's be ready. Worst case, suppose aptitude also they put a MSQ or NAT question. Let's be ready. That is why with every question the type is mentioned. So previously was 1 mark a MCQ question. Now please track. I told you, please track your marks. So all those who answer the first question, please place +1. Who could get the wrong answer, please write down -1, 3. And if you have not attempted, write down 0. Be very honest with yourself and look into this. Study the information carefully and answer the questions that follow. So very simple. Let's just make the family tree out of this. J is the mother of P. Okay, J is the mother. Mother is female. Mother of what? Mother of P. Right. P is the brother. Brother is a male. Brother of what? Brother of K. K is the mother. So K becomes female. Mother of V. Mother of V. Q is the brother of V. Now Q is the brother of V. Q is the brother of V, but there is no gender specified for V. Yes, guys. So, last statement, S is the father of P. If S is the father of P, dekho, P is already the child of J, na? P is already the child of J and S is also the father. J was mother. So logically S and J are married to each other. Very logically S and J are married to each other. Okay, now which of the option is correct? K is the wife of G? No. No. Is that true? Is that true? Yes or no? Dekho na. V is the child of K. Directly it is not seen. Ab dekho. V is the child of J. Okay. V and Q are brothers and sisters. Right. So they belong to same parent. G is the father of Q. G is the father of Q. So what does it mean? What does it mean? What does it mean? They have to be married to each other. So K is the wife of G. K is the wife of G. Yes, looks true. K is the daughter of S. K was the daughter of J, but S is daughter of both J and S. Correct. G is the father of V. Yes, G is the father of both Q and V. Right. And S is the husband of J. S is the husband of J. It is the MSQ question, all four correct. It is the MSQ question, all four is correct. Okay. Yes, Chandrasekhar, you can attend at least the common subjects like aptitude, digital, and beginning we have common subjects only. Don't worry, we have network, control, all those things coming up, Chandrasekhar. So you can attend, for at least 60-70% of the times. Right. Chalo guys, let's get moving ahead with the next question. Then quickly keep a track of your marks. This is MSQ. Agar sahi nahi hua hai, to no negative mark. Third one, verbal. Usually I don't deal with verbal, but I will give you the answer key and slight explanation of this, because I'll be taking care of the quantitative and the logical reasoning part. Okay. Oh, sorry. This was a typo error. I'm sorry. This was a typo error. According to false, nothing can be true. Then the question becomes wrong. Satya. It's a true. That is a typo error. I'm sorry for that. It's a typo error. Understood. Otherwise, nothing can be correct. Otherwise, nothing can be correct. Next, aa jate hain. The Buddha said, holding on to anger is like grasping. It's an underlined word. Grasping a hot coal with the intent of throwing it at someone else. You are the one who gets burned. You are the one who gets burned. Grasping a hot coal. Okay, now grasping has a synonym. Anybody? 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 Only the non-tech part can match with you, Shubham. Okay. Anybody, guys? Come on. What is the meaning of this? Select the word below which is closest its meaning to the word underlined above. Underlined above. Grasping. Grasping a hot coal. Yes, Prajwal. Okay. Grasping a hot coal. It's not burning. They are not burning. It's grasping. See my actions and understand. Okay. It's not igniting or burning. It's clutching. Option number C, correct. Clutching, because clutching also means holding something really very tightly. Yes, Frank. Very correct answer. Okay. Holding a coal so tightly that you are the one who are going to get burned. And the Buddha has explained this action similar to holding on to anger for somebody. Okay. So don't do it. You are the one at loss, not the other one. Okay. Yes, guys. Next question number 4. When she fell down the dash, she received many dash but little help. Very simple, very simple, very simple verbal question. When she fell down the dash, she received many dash but little help. Now look into the options, you'll understand. Options are stairs and stairs. What is the meaning of stairs? What is the meaning of stairs? Stairs means सीढ़ियां. सीढ़ियां. So she can fell down only from. She can fell down from stairs. सीढ़ियों से गिर सकते हैं. Then she received many. She received many. She will not receive stairs. No, she will not receive सीढ़ी. She received many stair. S-T-A-R-E. What is the meaning of S-T-A-R-E? Stair. किसी को घूरना. Right. किसी को घूरना. किसी को घूरना. Right. Look at deeply. Not only look. Look at deeply. Like घूरना किसी को. Stare. Okay. So look at very closely to somebody. Okay. So she received. बहुत लोग घूरते रहे but किसी ने help नहीं किया. She didn't receive any help but only people around were staring at her when she fell down the stairs. Option number A. Option number A. 1 mark MCQ question. ठीक है? Done. Next. The overwhelming number of people infected with rabies in India has been flagged by the WHO as a source of concern. It's a passage question and you have to see which of the following can be logically inferred from the above sentences. Okay. 1 mark MCQ again. The overwhelming number of people infected with rabies in India has been flagged by WHO as a source of concern. It is estimated that inoculating 70%. Inoculating 70% of pets and stray dogs against rabies can lead to a significant reduction in the number of people infected with rabies. Which of them can be logically inferred. Okay, number of people in India infected with rabies is high. Yeah, this is a concern. This is true, but let's read all the other options. This is definitely a concern. The overwhelming number, quite rapidly increasing number of people infected with rabies in India has been even flagged by WHO as a matter of concern. So yes, this is definitely true, but let's see if there is something better than this. The number of people in other worlds of the world are infected with rabies is low. Who is telling you? In India, it is high. In other parts of the world, I don't know. You can't say India mein high hai to baki jagah low hoga. So this is not at all a conclusion, dear. This is not at all a conclusion. Rabies can be eradicated in India by vaccinating. Now see, there was a word. It is estimated that inoculating 70%. Inoculating means protecting, these people or even pets, okay, by injecting them with a mild form of the disease. Okay, injecting them with a mild form of the disease. That is inoculating. Okay, now C option says rabies can be eradicated in India by vaccinating 70% of the stray dogs. Okay, and as well as pets, not only stray dogs, but रेबीज कैन बी इरेडिकेटेड. इरेडिकेटेड का मतलब क्या होता है? किसी चीज को जड़ से खत्म कर देना. टू फिनिश अप समथिंग कंप्लीटली, डिस्ट्रॉइंग इट अप, राइट? सो inoculating 70% of the pet can lead to a significant reduction, but it cannot eradicate it. It can reduce it, but eradicating is a larger word. Okay, किसी चीज को जड़ से खत्म कर देना, right? And stray dogs are the main source of the rabies worldwide. First of all, this is not worldwide data, and only stray dogs are not the main source. This is not mentioned. Other pets can also be there, right? So this is also not looking correct, but A is the perfect one. A to correct hai na? Number of people in India infected with rabies is high, and that is why if it was not high, WHO will not put it as a source of concern, isn't it? So A is the correct answer. It's not C or D. Okay. C is eradicated, and eradicated means destroying something completely. Jad se khatam kar dena. Okay, and that cannot be done by vaccinating. And that to only 70% of the stray dogs. All right, guys. Next question, coming back to the logical reasoning part now. 5 questions of 1 marker done. Okay, 5 questions for 2 marks for general aptitude. Then we start technical. Syllogism question. Come on, everybody, read and answer. Okay. Read the given statements and conclusions carefully, assuming that the information given in the statement is true. That is what is there with the syllogism. Information in the statement has to be assumed true only, even if it appears to be variance from commonly known facts. Okay, commonly known facts, like some chocolates are nuts. You may say some chocolates are not nuts. Okay, but still whatever is given, you have to take it to be true. Okay, decide which of the given conclusion, this is the set of conclusions that logically follows from the statement. Come on, everybody, read and answer. 1, 2, 3, 4. These are the 4 statements. I'll just write down 1, 2, 3, 4. It's a 4 statement based argument. 4 statements are given, and dear, tell me what should be the correct answer for this. Dear, quickly tell me what should be the correct answer for this one quickly. And let us get started. All right. Chalo. Yes, what it is? So first, let's write down the statement. And as I have taught you earlier also, the best method of dealing with syllogism is the Venn diagram. Okay, so let us take up these Venn diagrams and start answering. All cookies are nuts. All cookies are nuts. Very clearly, cookies are inside nuts. All cookies are nuts, right? Some chocolates are nuts. Some of the chocolates, not all. Some of the chocolates are nuts. So something in common. But all cookies were nuts. That means all cookies are inside nuts. Next aa jayega. All chocolates are pastries. All chocolates are pastries. So all the chocolates will fall under pastries, right? And no pastries are cherries. No pastries are cherry. Matlab nothing in common. So if this is pastry, this can be the cherries. No pastries are cherries, or not only this side, it could be this side also. Even this may be a possibility. Even this can be a possibility. This is a possibility. Pastries, the cherries should not be common with pastries. So it can be totally different, or it can be inside nuts or inside cookies, anything. But that's a possibility. Now let's have a look into this. Some nuts are pastries. Some of the nuts, right? Okay. Some of the nuts are pastries. Yes or no? Very clearly from this Venn diagram. Okay, actually some of the nuts are chocolates and chocolates are pastry, so that is why the first is true. The first stands out to be true. All cherries are nuts. All cherries are nuts. So this is a possibility. This is a possibility. Okay, I have given you the possibilities. Okay. So maybe if cherries are this side, they are inside nuts, or they may be outside nuts. What I only know is cherries is not common with pastries. Cherries is not common with pastries. So this becomes a maybe. This becomes a maybe. Okay. No cookies are cherries. No cookies are cherries. Now again, I don't know. The cherries, thoda sa aur yahan slice kar sakte hain. They may overlap also. We can't conclude that. No cherries are cookies. Again, maybe. Risk hai abhi bhi. Okay. Maybe is not a conclusion. Conclusion is 100%. And no chocolates are cherries. No chocolates are cherries. Yes. Chocolates inside pastries, and pastries and cherries are different. So chocolates and cherries will also be different. Only this is true. They cannot have under any condition any possibility. So 1 and 4. Only 1 and 4. Sorry. It's option number C. Only 1 and 4. Option number C. Everybody got this? Only 1 and 4. Option number C. Only 1 and 4. Option number C. Next question, guys. Quickly. Here it is. If A1, A2, etc. is an AP such that A1 to A24 is 225, and A1 to, what should be A1 to A24 continuity? A1, A5, A10, A15, A20, A24 is 225. Good question of AP, but very simple only. Good means you just have to apply a little bit of thought and calculations. Then what should be A1 to A24? 2 marks NAT. NAT bhi rakh diya hai, just in case sometimes they may ask NAT from General Aptitude. Quickly try everybody. Come on, ekdam solve kijiye quickly. Right. We just know that everybody, that the nth term of the AP is simply A1 plus the n minus 1 into the common difference. Common difference, first term, nothing is mentioned. Sum of the terms, that to randomly A1, 5, 10, 15, 20, 24. Ye 25 nahi, 24, and that is 225. On the basis of this, you have to conclude this answer. So, if I start with A1, A5, 10, 15, 20, 24, this is 225. So this is A1 plus A1 minus 4D plus A1 minus 90, sorry, plus 90, right? A1 plus 90, then aa jayega A1 plus 14D. Okay, so I'm just breaking up the terms and you'll get hold of the answer by that itself. Then A20 will be A1 plus 19D. A24 is the A1 plus 23D. This total is 225. What is the observation from here? Can we make a conclusion from here? Everybody, NAT question answer likho jaldi se. Right. So we have 6 times of the A1 plus 4 and 9, 13, 27, 46, 56, 66, 69. 6A plus 69D is 225. Look into this. 6A plus 69D is 225. You can cancel, I think, 3 also, but let this be. Let it be. Okay, so we have how much? We have the 6A1 plus 69D is 225. We have the 6A1 plus 69D is 225. What should be the correct answer for the given question? Now, given question is find the value of A1 to A24. A1 to A24. So A1, then it's gonna be A1 plus D. They are all consecutive now. A1 plus 2D, etc. A1 plus 23D. So dear, this is gonna be equal to A1 coming 24 times. There are 24 terms. So 24 A1 plus 1 plus 2 plus 3, etc. 23D. Sum of first 23 natural numbers. Summation 1 to 23. You can apply here. Okay, Deepto says 900, Dinesh says 828. Guys, any other answer for this NAT question? 24A1. Now, if you know to answer this question, if you know to answer, and while I'm solving, because we have to go with many questions, just put this on mute. If you know that, if you feel that you are able to solve, don't listen. First solve and then match the answer. Okay, solve and match the answer. If it doesn't match, then look into my solution. थोड़ी देर के लिए आप चाहो तो mute कर सकते हो while I'm solving it. First of sum of first 23 natural numbers, n plus 1 by 2. So this becomes 24A1 plus 12 into 23D. Out of that, let me take 4 common. So this becomes 6A1. Actually, I want that 4 common liya. And from 12, if you take 4 common, this becomes 3. 3 into 23, 69D. And that is the first result already given to us. 225. 4 into 225, 900. Correct answer by Deepto. And again, Dinesh also. Tushar, Naga Satish. Correct answer, guys. 900 is the very correct answer for this. Yes. 900 is the correct answer for this. बहुत ही बढ़िया. 900 is the correct answer for this. ठीक है? Next. All right. 8th question. 2 marks MCQ. A good question here again. Each of the letters A, H, I, M, dash, dash, dash. Some letters are missing, etc. up to Y. Appears symmetric when looked. Appears same. That is symmetric when looked in a mirror. When looked in a mirror. So mirror image bhi yahan pe combined. The mirror image that you commonly deal in the spatial aptitude. These are called symmetric letters, and other letters in the alphabet are asymmetric letters. How many 3-letter computer passwords can be formed with at least one symmetric letter? But how many symmetric letters are there? First is, ye jo symmetric letters hai na, how many? If you don't know your sample space, you can't solve a counting question. So it's a mirror image of letters concept combined with the counting question. But how many? How many? Few are given to us. Few are given to us. A, H, I, M. Right? Anything else? M. Yeah, etc. It's not only 5. This is etc., etc., etc. Then N. No. Just think. No need to draw that. Think in the mind, which is symmetric. Symmetric matlab, when you cut it from the between, the left and right part is identical. When you cut this from the between, the left and right is mirror image of each other, identical. Okay, so और देख लेते हैं. ना ना, N is not. ना N को बीच से कट किया तो ये ऊपर है वो नीचे. It is not symmetric. N is not symmetric. O, P, Q, R, S, T, U, V, W, X. ये पूरा symmetric है. Y तो mentioned ही है. This is the set of symmetric letters. This is the set of symmetric letters. How many, dear? अच्छा question बन गया ये. How many? How many? Total 11. How many of them? Total 11. Total 11. How many 3-letter computer passwords without repetition can be formed with at least one symmetric letter? At least one symmetric letter means how many symmetric letters? Maybe one symmetric or 2 symmetric or 3 symmetric. Okay. At least one symmetric. 1 symmetric, 2 symmetric, 3 symmetric. So ये तो ज़्यादा cases हो जाएंगे ना? What can you do, guys? Quickly, what can you do? 1 symmetric, 2 symmetric, 3 symmetric. What can you do other than this? What can you do other than this? Quickly. What can you do other than this? At least one symmetric. So better take the reverse case. Better take the reverse case. What is the reverse case? What is the reverse case? Okay, 0 symmetric. No symmetric. Okay, no symmetric. So all asymmetric. Okay, how many asymmetric? How many asymmetric? 15. In how many ways you can arrange 15? 3 out of 15. I want a 3-letter password. I want a 3-letter password. So how many permutations, how many arrangements are there out of 15 when you select 3 letters? 15 P3. And total की बात करें तो total will be 26 P3. Total passwords without this condition. Okay, total passwords where the letter can be symmetric, asymmetric, anything. Symmetric, asymmetric. The total alphabets are 26, na? Okay, so what's your answer then? What's your answer? 26 P3 minus the 15 P3. This is the hint I have given to you. Okay, and solve it up, guys. Your answer will come up as 12,870. Please solve it up. Calculations up to you. Will get it as 12,870. Calculations में यहाँ पे time waste नहीं करते हैं. 12,870. 12,870. 12,870. Please solve it up. You're gonna get that. You're gonna get that. Okay, done. Any confusions? Any doubt? Please ask me. Any confusions or doubt? Ask me. Next question. Again, a 2 marks MCQ. Bar graphs, DI, data interpretation question. Okay, if the cost per bearing unit in 2003 is 20% more than that in 2002, then the number of units exported in 2003 is how much more than that in 2002? Number of units exported in 2003 is how much more than that in 2002? that in 2002? Tell me. Cost per bearing in 2003 is 20% more than that in 2002. Then the number of units exported in 2003 is how much percent more than that in 2002? Tell me. 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 देखो, cost per bearing is 20% more than that in 2002. What is the total cost? Now look into this. Okay, there is a total income of MS Vijay Bearings Limited. There is some company whose total income is given in crore rupees, and this total income is the income from domestic trades. These vertical lines is domestic, and this hash lines, this what we say, these checked lines are from foreign trade. Okay, so what is the total income? What is the total income in 2003? Okay, 85 and 60. This is 145. 2002, it is 105. It is 105. It is known as 105. नहीं, अच्छा, उसके ऊपर है ना, ठीक है. So total is 60 only. There's a difference, and this is 85. Okay, right. Income from foreign trade, income from domestic trade. Okay, और ये total income ही given है यहाँ पे. Total income of that. Okay, total income of that. Now dear. Okay, what is the total income in any particular year? We can write down that total income as N1P1. N1 is the number of bearings. One of the portion of question is asking number of units. So let's say N is the number of units. N is the number of units, right? And P1 is the price per bearing, cost per bearing. Okay, let me write it as C1. Okay, N1 C1. C1 is the cost per bearing, right? Into the total number of bearings, total number of units will give you the total income, right? So if I want to discuss about 2002, so N1 C1 is equal to 60. But if I want to discuss about the N2 C2, this is equal to 85. The total is 85. Okay, ये जो bar graph है, this total is 85. This remaining portion you can treat it as that of, if they suppose wanted separately the income from foreign trade, so you can subtract the two and give me the answer. That is okay. But what is the data given? Cost per bearing in 2003 is 20% more than that in 2002. Cost per bearing is C. Okay, so C2 is 20% more than C1. 20% more than C1. The 1.2 C1, right? So you can write down N2 into 1.2 C1 is equal to 85, right? When you divide N2 into 1.2 C1 divided by N1 C1, this is 85 is divided by 60. What you are able to get, right? C1 cancel. You are going to get N2 by N1. N2 by N1 as something, right? N2 by N1 as something that you can calculate. Okay, you'll get it as something, but that is actually not required. If I tell you what should be the answer, you will get that something, but that is actually something that is not required. Clear? That is actually which is not something required here, but still मैं आपको बता देता हूं. $1.18. How much it is? 1.18, which means that N2 is 1.18 N1. मतलब N2 is the number of bearings also increased by 18%. Cost to 20% increase हुआ. The number of bearings in the 2003 increased by 18%. But they are asking what? The difference. How much more? The number of units is how much more as an absolute difference. Right? So how much more? The question is asking N2 minus N1, and that cannot be determined from the given data. You can determine it is 18% more, but as an absolute difference, to get that absolute difference, you need to know N1, and that is not given. You need to know N1. Something has to be mentioned, and that is not mentioned. So this cannot be determined. So sometimes you have to be very careful in, general aptitude. They can put up the questions which is sometimes directly talking about data sufficiency or indirectly like this is also data insufficient, and that is why you cannot determine the exact value. Okay. Agar question hota, then the number of units exported in 2003 is how much percent more? How much percent more? One line if I add, how much percent more? Then answer 18 हो जाएगा. ठीक है? right? How much percent more? Then the answer will be 18% nearly. Then you can determine. Otherwise, right now you can't determine quickly. The 10th question of the general aptitude here ready for you. It's a pure comprehension question. It's a pure comprehension question. Okay, so again I'm telling you, verbal I don't deal with, but I'll give you the answer key of verbal, and then let's start with the technical quickly. Moving into a world of big data will require us to change our thinking about the merits of exactitude. What is the meaning of exactitude? Okay, exactitude का जो behavior होता है, it is like always looking for exactness, always looking for perfection in the data, exact data, no approximations. Okay, right. So when we are moving into a world of big data, right, we'll require to change our thinking about the exactitude to apply the conventional mindset of measurement to the digital, because right now it's a digital data, a digital world evolving. Okay, connected world of the 21st century is to miss a crucial point. As mentioned earlier, the obsession with exactness is an artifact of the information. Artifact मतलब जो humans नहीं बनाया होता है, something like which is made by humans only. Good morning, Abdul. Of the information deprived analog area. Right. When data was sparse मतलब small in quantities, less data. When the data was less, every data point was critical, and thus great care was taken to avoid letting any point bias in the analysis. Right. So when the data was small, then you can be critical about every point, then you can worry about exactness. But now in this big data world, this exactness, this attitude, humans have to change. Okay. This is from Big Data, Victor Meyers, Schonberger and Kenneth Cukier. The main point of the paragraph is, the main point, there can be, 2 or 3 different points. Main point. Big data is observed with exactness? No. 21st century is moving towards a digital world. Okay, this can be slightly concluded, but this isn't the main point. Big data is observed with exactness? No. Human beings are observed with exactness. Human beings. It's not the data that is obsessed. Exactitude is not critical in dealing with big data. ये बोला जा रहा है. If you have to deal with the big data, you have to change your thinking of exactitude. Sparse data, small data leads to bias. No, ये तो reverse हो गया. Very clearly mentioned, when the data was small, sparse, every data point was critical, and then there was a great care taken to avoid letting any bias. Okay, so this is definitely wrong. C is the main point of the paragraph. Right. Main point of the paragraph. Right. Chalo. Right. Main point of the paragraph. All right. Important words I have highlighted in Hindi, Vijay. Don't worry. क्योंकि एग्जाम में आपको इसी तरीके से डील करना है. क्वेश्चन पेपर ऑफ गेट इज ओनली इन इंग्लिश. दैट इज द पॉइंट यू हैव टू टेक केयर, विजय. राइट. आ जाते हैं गाइस. नाउ कम ऑन एवरीबॉडी, क्विकली मूविंग टुवर्ड्स डिजिटल सर्किट्स. Quickly moving towards digital circuit. 1 mark MCQ question. An analog voltage of 2.89 volt is converted into 3-bit digital form by a counting type A to D converter with the reference voltage of 4 volt. What should be the digital output? What should be the digital output? What is the step size? Come on, जल्दी सा आंसर बता दो इसका. What is the step size first of all? What is the step size first of all? Resolution. Resolution also known as the step size. That is the reference voltage of 4 divided by the 2 raised to the power 3, and that is 0.5 volts. Okay, 3-bit A to D converter it is. Okay, so 0.5 volt, and now there is an analog voltage which is to be converted using counting type A to D. Now it's a 1 mark question. See, counting type ADC, why I brought this question is some students always draw the table for counting type A to D. Okay, when will the counting type A to D saturate? When it keeps counting up to a certain point, counter is on, it counts next, and then the conversion is done using DAC. Again, it is compared through the comparator, and then the counter keeps counting. But no, अगर आप हर एक बार ऐसे करोगे 1 mark के लिए, तो then it's going to be lengthy. What is that you should know is, what is the voltage to be converted? 2.89. Okay, I'll tell you. If you don't know, listen, directly the shortcut for counter type ADC, 2.89. I will divide the 2.89 with the reference voltage, because we move in the steps of reference resolution only, not reference voltage, resolution. We move in steps of LSB. Okay, what is the answer we get? Now this is, no need to calculate exactly, it is 5 point something, right? It's not 6, it's not 5, it's 5 point something, right? Take the upper integer of that, which is known as the ceiling function. What is the upper integer of that? Dear, it is 6. The upper integer of 6, right? And 6 बोले तो 6 बोले तो 110, 6 बोले तो in digital 110. That is the shortcut to deal with the counter type ADC problem. Prajwal, correct answer. Yes, it's 110. That is the C, right? No, mock test will not be daily, Vijay. We'll bring you periodically. Okay. But yeah, one thing we are planning daily for you. I want to know your opinion also. Tell me, dear. Tell me, dear. Right. We are planning to bring you a complete session subject-wise on the past 5 years previous year question. Right. Some of you might have solved. Some of you still might have neglected PYQ. Right. किसी ने किए होंगे, किसी ने पूरे नहीं किए होंगे, किसी ने आधे किए होंगे. So guys, if we bring up 5 years PYQ questions subject-wise, like one session, suppose digital electronics, all 5 years, 2022, last 5 years, 22, 21, 20, 19, 18, 18, 19, 20, 21, 22. If we bring you that, right, how many of you will be interested? Let me know the students' opinion, what students need. Do you want such live sessions, 5 years PYQ, right? Past 5 years PYQ. Do you need that? Because we are under the planning stage. If you think you need that, we'll plan that. Past 5 years PYQs live. Because past 5 years will give you the perfect analysis of what GATE is thinking about, what GATE is looking for. What GATE is looking for, what GATE is thinking for. Solutions, discussions, past 5 years PYQ subject wise. एक साथ नहीं, subject wise, like digital, control, aptitude, then signals, EDC, analog, subject wise we are going to plan. All right. Chalo. Cool. Okay, so just put down your opinions, everybody. Just put down your opinions. Chalo. Have a look into the next question. The function f is designed with a decoder and multiplexer as shown in the figure. What is the minterm form of the function? It is a function of PQR. PQ are the inputs to the decoder and PR the inputs to the select line of the multiplexer. Okay. Chalo. Cool. Yes, tell me. The function f is designed with a decoder and multiplexer as shown in the figure. What is the minterm of FPQR? What is the minterm of FPQR? Let's get... Where is that picture again? I didn't copy kya? Chalo, no problem. Yahi kar lete hain. So what is the function of PQR? All right, guys. So we know that... Yahi likh dete hain. We know that the function is finally the output of multiplexer. It is the output of multiplexer. It's a simple question. Don't think ki do circuits have 1 mark ka question again. It's a very simple question. Select line 0, 0. That is P bar, R bar. 0, 0 pe I get I naught. 0, 0 pe I will be getting I naught. And what is I naught? It is the output of decoder. Let me write down the output of decoder. The decoder will give you all 4 possible minterm combinations of 2 input. Right. That is, first one will be P bar, Q bar. Next is P bar, Q. Next is PQ bar. Next is PQ. 0, 0, 0, 1. 1, 0, 1, 1. Right. Clear. So what is the first input to the multiplexer I naught? That is P bar, Q bar. Plus. Now select line 0, 1. Then select line 1, 0. Then select line 1, 1. These are the possibilities of select lines. With the select line 0, 1, what is the multiplexer input I1? That is P bar, Q. What is the select line 1, 0? The multiplexer ka input I2 select hoga, that is PQ bar. When the select line is 1, 1, I3, that is PQ, will be selected. Now this is nothing. Dekho, P bar into P. In the Boolean, in the digital world, X into X is X. X into X is X. So P bar into P bar will be a single P bar. So the F is equal to P bar, R bar, Q bar. Next P bar, again P bar into P bar is a single P bar, P bar, R, Q. Next is again P into P is 1. So you have P, R bar, Q bar, and dear last mein aayega P, R, Q. Okay. So this is 0, 0, 0, 0, 1, 1, 3, 1, 0, 0, 4, 1, 1, 1, 7. 0, 3, 4, 7, 0, 3, 4, 7. Option number A mark kar diya, dear. It is the option number A marked. It is the option number A marked. Everybody done? All right. This is the final answer for you. Correct hai? Yes. Yes, Prajwal, correct answer. बहुत बढ़िया. Okay, give yourself 1 mark if you have done it correctly. If you have done incorrect, do -1/3 also here. Next question. Okay, from digital, 2 marks MCQ. Good question. 2 marks MCQ. Good question. For the digital counter shown below, okay, with the outputs Q0, Q1, etc., where Q0 indicates the LSB of the count value, the correct statement when the switch SW is closed. When the switch SW is closed, what is the correct statement? When the switch SW is closed, what is the correct statement, dear? What is the correct statement? Okay, tell me. When the switch is closed, let's have a look into the detailed analysis of the circuit. So when you close the switch, what is going to happen? A becomes 0. Now A is the input to the preset input of this flip-flop. This is the preset. Ye Q0 yahan pe aayega. This Q0 should be a little bit separated. Okay. It's not PR, Q0. PR is the preset input and Q0 is the output of that particular flip-flop. This is Q0. Okay. And what type of preset? Look into the symbol. It's an active low preset. It's an active low preset, dear. Right. So if A is equal to 0, the preset is set. The preset is ready now because it's an active low. Because it is an active low. Active low hai and you receive active low. This means Q0 is always set to 1. क्योंकि इसको fix कर दिया है आपने तो Q0 is always set to 1. The LSB is set to 1. There is no role of the input or clocking here. The LSB is set to 1. The LSB is set to 1 because by default the presets and the resets are asynchronous presets and resets. Okay. All right. We have this coming up with the option number A. Very good question, guys. Very good question. करना है digital का ये 2 marks question. Very good question. This is. Okay. Very good conceptual question. Now, dear, A 0 हो गया है. A 0 है. Right. So output of the AND gate is 0. Q0 is 1, but any input 0, output will be 0. So A bar will be 1. A bar is 1. So what do you get here? 1 into clock is equal to the clock, right? So what do you get here? 0 plus clock. So you get the clock here. That means the next flip-flop is getting the clock, okay? And it is a ripple count again. The output Q1 goes to the clock of next one. The output Q2 goes to the clock of next one, and etc., 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 etc. Okay. Tell me. Acha, by the way, what type of counter it is? What type of ripple counter it is? What type of ripple counter it is? The clock connection, if I see the clock connection, clock is coming from the Q output to the positive edge. The flip-flops are positive edge triggered. The flip-flops are positive edge triggered. The clock is coming from Q to positive edge, and such a counter is known as a down counter. ये पूरा आपने पढ़ा होगा. If you have actually studied digital in the good manner, you should be knowing this. Q to negative edge is up counter, Q to positive edge is a down counter. Right. Now, how many flip-flops are there? Let's assume 3. Let's assume 3 to get an answer. Right. Assume 3 bits only. Right. Assume the 3 bits only. Q2, Q1, Q0, but Q0 is always set to 1. Q0 is always set to 1. Q0 is always set to 1 because it is in the preset state. It is in the preset state. Rest is going to be a down counter. So let's start with 1, 1. Down counter. So let's start with the highest number for two particular bit. Right. इसको separate किया. Q0 is always 1. Right. So 1, 1. Then 1, 0. Then 0, 1. Then 0, 0. And then it repeats. And then it repeats. Right. What is this? 7, 5, 3, 1, 7, 5, 3, 1. You can try with 4 bit, you can try with 5 bit. Bhaiya, LSB हमेशा 1 है, and LSB is equal to 1 only for odd numbers. The simple logic is this table is for your explanation. But you can say that Q0, which is the LSB, it is 1 always. 1 always, and that is for odd numbers. That is for odd numbers. It will only count odd numbers, but you have to do this clock analysis also. यहीं पे मैंने आंसर नहीं बोला. Here also I could have said the answer Q0 is always set to 1, so it is counting odd numbers. No, maybe if the clock is not received here, if I change little bit of the configuration of AND or gates, if the clock is not received, then the counter stops. Counter stops. There is one option like that also. Counter stops counting. Counter stops counting. Counter stops count नहीं होता है. Counter stops counting. So that is why we have to do the analysis of the rest of the circuit as well. And with that, our answer is the counter chords. The counter outputs are only odd numbers. They're only odd numbers. Good question. Good question में classify करेंगे इसको. ठीक है? All right, perfect. Next question, number 14 from the digital, number 14 of the entire paper. Okay, this one it is. Which one of the following is true for the following function? A 2 marks MSQ question, dear. A 2 marks MSQ question. Summation M 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, 15. There is a function in the midterm list. You have to tell me how many EPI, how many PI, how many RPI. Then you can also say how many SPI, right? And these are whether the prime implicants as well as essential prime implicants. We have to look into it. We have to look into it, and we'll look into it quickly. Again, I'm telling you that if you also know how to solve this question, if you are clear in solving the question, so by the time I draw, by the time I solve, you can put this on mute, okay, so that we save time also. You can put this on mute and try solving your own. Just try solving your own and then match your particular answers with me. The best way of dealing with the PI, EPI we know is the K-map and the pairings and the groupings within the K-map. Okay, what do we have? 0, 2, 3, 5, 7, 8, 9. Fill कर देते हैं सारे midterms को. Okay, we have 0, 2, 2 and 3. Then we have 5, 7, 8, 9, 10, 11. 8, 9, 10, 11. 10, 11 reverse होता है because of gray code, and 13, 15. This is 13, this is 15. Now we need to highlight all possible groupings. Now we need to highlight all possible groupings, right? Every column can make a quad. So this is column completely filled. This is a quad. This is the next quad. Okay. 4 corner ones make a quad. We all know that in the 4 variable map. This is a central quad. अच्छा, एक एक करके लिखते जाते हैं, otherwise you might be confused later on. This is B bar, D bar, right? This column, this is in C as well as D. This is CD. This row, this last row, this is in A and lying outside B. So A, B bar, ये 3 हो गया, right? Now let's work on more. Okay, this is a central chord very clearly. This central chord, this is in B as well as this is in D. So this is BD. I'm writing the names as well just for option number D. Okay, just for option number D. Then we have, see, prime implicant means make all possible groups. Again, voice issue hai kya? Okay, just for option. No, it is clear. It is clear, Rams King. So prime implicant means all possible groups that you can make out of this K map, right? Whether it is to be included in SOP form or not, I don't know, but you have to make all possible group. It's like a prime implicant is like a puzzle problem actually. Okay, so this is also a quad, and this quad can be named as lying within A and the central 2 columns, that is D. This is AD. Anything else? 5 to ho gaya hai. Anything else? Anything else? Anything else? The first row and last row. Have a look into this. The first row and the last row. This also makes a quad. These two, one, these two, one. That's clearly a quad which cannot be combined with anything. That is the largest quad. All possible groups in the K map to be taken to make prime implicant, and this is lying in C and outside B. This is B bar C, right? This is B bar C. So what are your PIs and what are your EPIs now? EPIs के लिए what is the procedure? I will highlight those midterms. So how many मैंने लिख दिया है? 1, 2, right? 1, 2, 3, 4, 5. Anything else? 6. We have 6 PIs, correct? We have the 6 PIs, right? Now, I will highlight the midterms which are under a single group, which are under a single PI, then that PI is essential. That PI is essential, right? So, B bar, D bar is essential. BD is also. BD is essential also. No, ये B bar, D bar वाला है. I'm sorry. This is essential. Next आ जाते हैं. Look into this. This midterm is also covered under a single group. So, this also is essential. This prime implicant is also essential. Now this midterm is covered under 2 groups. This is covered under 2 groups. This is under multiple group. यहाँ पे multiple group, multiple group, multiple group, multiple group, multiple group. So there are only 2 midterms which I can star mark. The procedure is highlight the midterms which are covered under a single group, single prime implicant, and that prime implicant is essential. So how many essential? How many PI? Everybody. PI is 6. EPI is 2. EPI is 2. So definitely how many non-essential? How many non-essential is 4? Okay. Out of these non-essential, na, some will be RPI, some will be SPI. I hope you know all of this theory. I hope you know all of this theory. So if I only take the PI, na, देखो ध्यान देना. If I only draw the K map, out of the EPI. What are the EPI? B bar, D bar and BD. Right? B bar, D bar corner ones and BD is the central chord. That is known as the central chord. Okay. So if I only draw the EPIs, there are some minterms which is missing. What are the minterms which is missing? This is gone missing and these two are missing. Dear, to take this particular minterm, you have to select one more chord. Na? You have to select one more chord. You have to select one more PI. What is that one more PI? It can be either this column or it can be either this particular chord. Right? So the one you select, which one you select? Sir, it is your choice. Sir, it is your choice. You can select the column as well. You can select this chord as well. It is your choice. One of them is selected. One of them is reduced. Similarly, still this one is left. Still this minterm is left. So how will you cover this minterm? How will you cover this minterm? Either you can take this chord. Right? इसके लिए अलग color ले लेते हैं. Either you will take this chord or either you will take the row. Either you will take the row. Okay. So again, one more to be selected, one to be reduced. You don't need both. So out of the remaining four, two are reduced, two have to be selected. Study this if you have not studied this, because this is the important topic. So two are reducible, two have to be selected. So now let us see what is the correct possibility. Number of EPIs are 2, correct. Number of PIs are 6, that is correct. Number of RPI is 1, no. 2 RPIs will be there. BD and B bar D bar are PI as well as EPI, correct. The answer for this multiple select question, dear, is A, B, D. The answer for the multiple select question, dear, is the A, B, D. Everybody, good question hai, theek hai, don't worry. Good question leke aaya hu main so that you learn all types of questions and all types of variety. Right? Next question, guys. This was the MSQ. Next question is here. 2 marks NAT question from digital. Consider the circuit shown in the figure. Okay. If the input clock frequency is 6 kilohertz, then the output frequency is dash kilohertz. Solve it up quickly. Everybody, solve it up quickly. Right. Consider the circuit shown in the figure. If the input clock frequency is 6, the output. This is simple. Yes, simple hai yaar, because 2 D flip-flops are cascaded. It is a shift register based question. Let's say this output is Q1, this is Q2, and when you write down this table, Q1, Q2, and then we have F out, that is the output whose waveform, whose frequency is required, and the F out is the product of Q1, Q2, right? Q1, Q2 can start from 0, 0, but dear, what is the Q2 plus? इसको समझ लेते हैं. Because it's a shift register, Q2 plus is equal to the D2, its input, but its input is coming from Q1, right? So whatever is the current value of Q1 goes to the next, right? So this 0, this will slide and it will come up here. Okay. But what about the Q1 plus? Dear, what about the Q1 plus? The Q1 plus is equal to the input D1. That is actually known as the serial input actually. This is actually the serial input, and that is coming from where? Complement of the first and complement of the second flip-flop are ANDed. So this is Q1 bar multiplied by the Q2 bar. Q1 bar is multiplied by the Q1 bar, or that can be taken as Q1 plus Q2 ka whole bar. NOR gate. If any of the input is high to NOR gate, output should be 0. That is what we know for NOR gate. If any of the input is high, output will be 0. If both the inputs are 0, then the output will be high. So correspondingly, dear, I have added one more column here, that is regarding to the serial input. So Q2 plus is equal to D2 and D2 is equal to the Q1. ये तो shifting हो गया, right? Now at 0, 0, what is the serial input? 0 plus 0 is 0, complement लेके 1 आएगा, and then the serial input has to be slided to Q1. So this comes here 1. This is the procedure of solving the question, right? Then what is the NOR of 1, 0? It is 0. Now do the right shifting, 0 and 1. 0 and 1 ka NOR is again 0. Okay, now do the right shifting 0, We come back to the original state. Now it repeats, right? Now it just repeats. This is already repeated, right? So let's consider the analysis up to this point. And what is the F out? F out is the OR gate of Q1 and Q2. This is Q1 plus Q2, right? So 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1. So F out is high for 2 clock period and it is low for 1 clock period. Very clearly, it is having a time period of 3 clock period. It is having the time period of the 3 clock period, right? It is 0, then it is 1, then it is 1, right? This is 1 T clock. For the first clock cycle, it is 0. For the second clock cycle, it is 1. For the third clock cycle, it is 0, and then it repeats, right? So what is the time period of this waveform? Time period is 3 times the clock time period, right? So what is the frequency? It is the reciprocal of time period. So 1 upon 1/3 of the clock frequency. The clock frequency, dear, is known as the 6 given, Anna, 6 kilohertz. So what is the answer? Is 2 kilohertz. NAT question, decent and simple question, I can say. 2 kilohertz, 2 kilohertz, 2 kilohertz. ये तो हो जाना चाहिए. This one is simple. That counter one was a good question, but this is simple, right? All right. Good afternoon, Misra. All right, guys. So now time to move on towards, these are 5 questions of digital, making, if I write down here, I'll write down the weightage actually. So digital, what I have done is 2 questions of 1 mark and 3 questions of 2 marks. Total 8 marks is the digital weightage, which is justified because for EC around 8 marks is normally the weightage of digital circuits. Sometimes it goes plus minus, but this is the average weightage for EC student for digital circuits. Time to now, just a moment. Time to now move on towards the control and the network theory. The control system, and again according to their weightage the questions will come. Okay, for the control and network theory, we are going to have Phanindra Sir joining us live right now, guys. So if 5 faculties are going to take one by one, so immediately, guys, just don't worry, maybe there is a 10 seconds of buffering, 10 to 15 seconds of buffering, it may be there, not more than that, okay? 10 to 15 seconds, but again, 2 important subjects, control and network. The questions according to their proper weightage in the GATE examination is going to be taken by Phanindra Sir. And we have all subjects just have to be live. We have EDC, analog, math, signals, communication, EMT, everything coming up, guys. So just wait on, and we have Phanindra Sir coming live. There will be a magic on screen and suddenly Phanindra Sir is going to be live. I hope you have scored good in this part. Keep scoring well in the other.
Hello. Good afternoon to every one of you, and specially welcome to EC students, and special welcome to this India's open mock test. We came up with almost all subjects which are there for GATE examination with exactly the weightage of GATE examination. There may be a little bit ups and downs in the final GATE examination. But before going to start, let me welcome every one of you. Satyasri, good evening, good afternoon. Bhavana, good afternoon. Of course, Dinesh, good afternoon. There are n number of students are there. As Rakesh Sir have rightly said, we are all here to discuss all the subjects related to the GATE syllabus. In fact, you must have patience to go through all the subject one by one. And all the way, as usually, Rakesh Sir has extremely done well. He have completed the subjects of quantitative aptitude. Followed to that, he also done with the digital electronics. And now it's my turn. I am here to deal with the subjects of circuit theory and control system, 2 favorite subjects to many of you, right? Vijay Solanki, good afternoon. John Peter, good afternoon. Manoj Kumar, good afternoon. We actually started to have the session in the, like 11:30 or 11:45. But after seeing your interaction, we also got a lot of energy. So the time may be a little bit more, but let us do all the way, let us participate in the discussion and learn both the sides, okay? Right, guys, please let me know in the comment section. Are you guys really excited to know the questions related to circuit theory as well as control system? Please let me know in the comment section. I want the energy should be flowing from both the ends, right? So I should give the energy, at the same time you should motivate me to teach the questions to the deep level. Clear? So Satyasri is saying yes, yes, yes. Very good, Dinesh. Excellent. So let's start with the first question of the circuit theory. But before going to start the circuit theory, I would like to explain. Maybe there are some students who don't know about myself. For the new students who are there in the channel, all the way you can see my credentials. My name is Phanindra. All put together, I have an experience of 12+ years in teaching industry, guiding for GATE students as well as ESC students. Of course, this is more than sufficient. Let's not wait, waste the time in the discussion about myself. Let's quickly get into the actual content of the discussion. those people who are planning to join for 2024, you can avail this scholarship by participating in the examination. Well, let's get into the first question of the circuit theory. Everyone be accurate and at the same time be fast also. Solve the first question which is visible on the screen, right? So the question number 16, in the alignment of the overall question paper, find the voltage and the current in the circuit shown in the figure. So there is a circuit here and you require to find the voltage as well as current. Both you have to find. In fact, it may be a numerically answered type question. Okay. So let me say this is the NET type question. So everyone, Deepak Sakya. Yes, good afternoon. Well, it's a numerically answered type. All of you please see this question. Every time when I deal the question, first I will give 30 seconds to 40 seconds for you to read the question and then I will give the logic. Of course, if we all solve the question detailedly, then it will take long time to complete the mock test. So what I do is I will explain the logic, I will also show you the procedure and I will leave the calculations to you, and it is you have to put down your pen and paper and complete the calculation and select the answer. Clear? Very good. Rams King has given the answer. Excellent. Very good. Nice. So it's really crazy to see such a fast answer. He has mentioned the answer within 1 minute. Harsh also has given. Excellent. Right? It's a simple question, right? So in fact, the first question, which is of 1 mark, naturally it will be very simple. It is a simple KCL. How can I write this one? So this could be written as a 0.5 times of I naught. Am I right? And of course, this is going to be 3 ampere current. So let us say this is going to be 3 ampere current. So 3 amperes is coming this side and 0.5 I naught is coming this side. So this current, which is all the way coming out to be, can be written as I naught is equal to 3 amperes current plus, we know that this could be 0.5 times of I naught. Simple. So therefore, what should I say? I naught into 1 minus 0.5 if I take, then it will become 3 amperes here. So then I naught will be equal to 6 amperes. This is number 1. First, of course, I am waiting for the answers from all of you. Please participate and let me know. In case if you find any difficulty with the voice or else audio or video, please let me know in the comment section. Bhavana also has given the answer. Right, very good. So what would be the output voltage here? Can you please tell me? It's very simple. Output voltage across the 4 ohm resistance can be written as the 4 ohm resistance that should be multiplied by the I naught. Means it's a simple Ohm's law, right? Voltage across a resistor is equal to current into resistance. What else you want? It is not a rocket science, right? So 4 into 6 ampere. Therefore, I could write this as a 24 volt. Clear? Very good, very good. Guys, you seems to be so fast. In fact, you are faster than me, right? So, well, the answer to this question is 6 amperes as well as 24 volt. We have done with the first question. Let's move on to what are the concepts you have learned in this question. So, you might have learned 2 things, KCL and then Ohm's law, and more importantly, we have used the dependent source also. Clear? So, these are the 3 things you have learned it, right? Now moving ahead to the next question. So the next question is the 17th question in the sequence. This is also a 1 mark question, but let me read the statement of the question. The Thevenin's equivalent circuit of the network shown in the figure is across 1 and 2 terminals. So what would be the correct answer for this question? Once again, I am showing the figure and I will wait for 30 seconds. Read the statement of the question, understand the figure, and then try to put out the actual information on the paper and get the answer. Every one of you, be fast. So when you look at the statement of the question, can you tell me, is it the first case of the Thevenin theorem or the second case of the Thevenin theorem or the third case of the Thevenin theorem? Even if you don't want to go with the cases also, no problem, but we all can understand by looking at the figure, we have no idea about, we have no independent sources, correct? So we have no independent sources. Well, Harsh is saying that yes, it is a third case. There are no independent sources. If there is no independent sources, then we can say VTH voltage or the Thevenin voltage straight away it is equal to 0 volt. But how do we find the RTH in this case? Any one of you? How do we find the RTH? If you want to find the RTH in the absence of independent sources, when your circuit is having only dependent sources, then we must introduce the independent source. We must introduce the independent source, whether that is a voltage source or current source, that is up to you. But let me go with the voltage source. That means I am introducing a voltage source. Look at that. This could be taken as VDC, and I am keeping applied. So this is 1 volt. Let me take 1 volt so that the calculations will become really very easy. So it is up to you. You can take how much voltage you want, right? Very good. Such a 3 like you, when you really made it very good. VDC is equal to 1 volt. In fact, Harsha is the first person who has rightly answered that this is a third case. Very good. Now, if it is VDC, now what we should do here? So 1K and 9K both are connected in series. Therefore, I would be saying that this is all the way around 10K resistance, right? So let me say all the way, this is going to be 10 kilo ohm resistance, right? So 10 kilo ohm resistance. Good. So and then here we do have like 100 ohms here. Guys, any answer? Please let me know in the comment section. We have to be fast, right? So and then here 100 ohms is there. Of course, we are calculating. In fact, we have equated. In fact, look at that. This is the terminal 1, I could say, and this is the terminal 2, and we have applied 1 volt like this. Correct? 1 volt like this we have applied. And at the same time, there is a dependent current source, we can say, all the way. This is the dependent current source, and dependent current source is pumping the current into terminal 1, right? So therefore, I should say this is going to be 99 times of IB here. Correct? So there is a current, of course, which is coming like this. This is going to be IB here. Now, how do we solve this one? Any one of you, what actually you want? You require, because this is IB means obviously this could be equal to IB only up to here, right? And this is 99 IB means no doubt that this is going to be 99 IB only. Correct or not? Now, if it is 1 volt means you will be having 1 volt voltage source across this, then the current that is flowing here is going to be 1 divided by 100 amperes. Am I right or not? So any answer from your side? Apply KCL. Very good, very good. Right, Tushar, I think your answer is wrong. Please check once again, right? So 1 by 100 amperes current is going here. Now you must know what is the amount of current that is delivered by this. Let us say this current is I here. Clear? So if I say this current is I, then no doubt that, what should I say here? This is going to be how much here? 99 IB, correct? Plus I here, correct? 99 IB plus I. So therefore 99 IB and IB is coming here. So therefore I can say 100 times of IB plus the current I, all the way this will be equal to 1 divided by 100. Clear? So that's it, guys. We almost at the end of the solution. What is IB now? Now can you tell me what is the IB value? IB is the current that is flowing here, but we know as 1 volt is applied here, same 1 volt will be there across this resistor also, correct? So what is IB value now? IB value is equal to minus 1 divided by 10K. That means 10 to the power of 4 here. Clear? So therefore let me write down minus 1 divided by 10 to the power of 4 here and plus I here, and that must be equal to 1 divided by 100. Everyone be accurate and fast. Let me know what would be the final answer here. What would be the final answer here? So Tushar has given the answer long back. Let us see whether he is correct or not. So therefore it is 1 by 100. So take 1 by 100 to that side. Then you will going to get I is equal to 2 by 100 here. Correct? So 2 by 100, it is going to be 1 by 50. Thank you very much, Tushar. I have mistakenly taken your, I have not read your answer clearly. But thank you very much. It is going to be I is equal to 1 divided by 50. Am I right? Please look at the solution, all of you. I need your support. Everybody must be very fast in answering the question. This is going to be 1 by 50. If so, what is the value of RTH now? Now how do we calculate RTH? Simple, RTH is equal to whatever the voltage we applied here, that is VDC, 1 volt, divided by the value of the current that is coming out of the network, coming out of the voltage source. So therefore, we can say 1 divided by 50, all put together, this will be equal to 50 ohm. Is it correct? Every one of you please see. Yes sir, Bhavana has given the answer, but it was the Tushar who has given the answer correctly. Earlier I have read it wrongly. Okay, so 50 ohm is the correct answer for this question. Good question, right? So Thevenin theorem, superposition theorem, maximum power transfer theorem, these three theorems are very important, and you must know clearly about each and every case of the Thevenin theorem. Followed to that, each and every case of the maximum power transfer theorem, especially in the AC circuit. In case if anybody don't know those concepts, please watch my recorded lectures which are available in BYJU'S Exam Prep app, and I'm very sure you will love that. Simply amazing those lectures are. Well, let's get into the next question without wasting the time. So this is the third question. Question number 3. The value of Z in the figure which is most appropriate to cause the parallel resonance at 500 Hz. Clear? So we require a parallel resonance at 500 Hz. So what we have to do now? In a simple and a very vague language, one can understand that whether it is series resonance or parallel resonance. Whether it is series resonance or parallel resonance, what should happen? Your impedance or the admittance must be only real value. Clear? Must be only real value. So what we can do here is, let us take this as the terminal 1 here and let us take this as the terminal 2. Now if you see the equivalent impedance, that is Z equivalent. Clear? How do we find the Z equivalent here? So he is saying that the value of Z in the figure which is most appropriate to cause the parallel resonance at 500 Hz. If you look at all the way, everything is looking like an inductor here, right? Everything is looking like an inductor. All 4 options are related to inductor. What does it mean? I can say that there is an inductor, but I don't know what is the value of that. Clear? There is an inductor, I don't know what is the value of that. So let us call this as L1 and let me call this as L2 here. Okay, but L1 value we need to find out. Otherwise, let me take in the other way around it, because known quantity should be taken first and unknown quantity should be calculated. Correct? So let me take in a simple way. So let's call this as a L1 here and let me call this as L2. Tell me what should I do now? Now you need to find Z equivalent here. So Z equivalent could be written as 5 ohm plus, and parallel combination of these two inductors here, L1 and L2 both are connected in parallel. So if both are connected in parallel, then you will going to get J omega into L equivalent. Am I right or not? J omega into L equivalent. Correct or not? Right? So then you must go ahead and find out properly here. So 5 plus, what is the value? Here if you look at, so you require parallel resonance here, right? So then moving ahead, any answer from your side? I am waiting for your answer. So for every question which is related to resonance, whichever is related to resonance at 500 Hz means, now it means that the resonant frequency is given. How much is the resonant frequency? 1 second. Resonant frequency is given as, resonant frequency, I would be calling this as a 500 Hz here. Correct? Resonant frequency is 500 Hz. So therefore omega can be calculated as 2 pi times of Fr. Therefore it would be easy to say that is 2 pi into 500 radian per second. This is considered as your omega r. Any answer from your side? Bhavana, Dinesh, Tushar. Tushar, have you got the answer? I just want to know from your side. Just calculate the equivalent impedance and equate. Otherwise, if you don't know this impedance, just take that as a Z and calculate the equivalent impedance. And you must understand that every time when we calculate the equivalent impedance, you will be having some real part plus J into imaginary part. Correct? J into imaginary part. Now, at resonance, what should happen? Any answer from your side? At resonance, whatever the imaginary part is there, that must be equated to 0. So if you equate it to 0, then you will going to get the answer which can be the perfect answer for the given question. Hope you understood this one, right? Shall I go to the next question? Question number 19th, right? In fact, this is the 4th question, I guess. So what is the approximate steady state current in the circuit shown below, right? In the circuit shown below. Guys, I am not seeing any response from any one of you. Is everything is okay? Are you able to hear me? Please let me know in the comment section. Are you able to hear me or not? Are you able to hear me? Both audio and video are clear to you? Yes, yes. Thank you, Bhavana. Thank you very much. So what is the approximate steady state current in the circuit shown below? How do we evaluate this? Yes, Tushar. Yes, yes. Sir, I can't get the answer. Why? In RL circuit, how resonance will occur? Oh, sorry. Then that is, yeah, I understand that. So, yes, correct. Resonance will not occur in RL circuit. Basically, it must be RC circuit. Actually, I would like to tell this concept only, right? So, there is a small mistake. Please consider this mistake. And who said this one? Surjit has done, and love you, Surjit. You are right. Actually, we must have capacitor. Even here, when you write L equivalent, you will not get that, right? So I am extremely sorry, right? So you are correct. So I have not identified this because I am in rush to complete the things. but you must understand that this is a Z, right? So here you must have a capacitance here. So because then only there is a possibility of having a resonance, right? And everyone, Tushar, Bhavana, Dinesh, whoever are there in the chat box, Harsh and Satyasri, every one of you, let us take a minute and appreciate Surajit, who has actually opened our eyes here. Okay, so we must have capacitor there. When we have capacitor there, then obviously your Z equivalent will going to change. Am I right or not? Your Z equivalent will going to change, right? So now take a minute here and keep this as the capacitance, and then again calculate the overall impedance here. Then only we can say, right, here it will become 5 ohm and plus J into something will going to come here, and this part must be equated to 0. Please don't try to consider all these 4 options. Clear? So all of you are okay now? I think this is the doubt you people are having, and Surjit has came up with the correct line and he has countered, and I like that countering, right? So imaginary part must be equal to 0. Let's take the capacitor there, because of course if you take capacitor, obviously these 4 options will not going to match here. Clear? Yes, yes, very good. Thank you very much, Bhavana. And most importantly, as I was saying, not only in RL circuit, right? Not only in RL circuit, even in RC circuit also, we will not going to have resonance. Clear? We will not going to have resonance. Resonance occurs at least you have, if you have at least 2 energy storing elements. Why? Because at resonance, the energy of the capacitor should be exchanged with the inductor. That means the energy of the inductor will be transferred to the capacitor. The energy of the capacitor should be transferred to the inductor. Whatever the way you have placed, that doesn't matter. Clear? So for that reason, you at least must have 2 energy storing element. Then only you will going to get the resonance. Therefore, I must say either in RL circuit, either in RC circuit, you will not going to have resonance. You will going to have resonance in RLC circuit. Is it fine, Surajit? Please let me know. Confirm in the statement. You are the first person who came up with this. Actually, I would like to tell that concept only, right? But in the past, in the momentum, then I missed that point. Thanks for that. Thanks, really thanks for that. Right, Surajit? Is it okay? Surajit, yes. Yes, yes, yes. Good, good. Now let's get into the next question. What is the approximate steady state current in the circuit shown below? So what would be the approximate steady state current in the circuit shown below? So they are asking the question like, what is the amplitude of the current that can flow here? In fact, I can even say either peak value or RMS value. That is not the question here. But what is the amplitude of the current? How do we find that one? How do you find this one, right? So please see here. So omega should be given. So let us say, what is the approximate value of the steady state current at a low frequency, that is 1 radian per, sorry, it's given here. It's given. What is the frequency? Can you see the question and tell me? Every one of you, please let me know in the comment section. Can Z be series of L and C? Yes, yes, it's possible. Timothy, it's possible. It's possible. Everything is possible. Okay. Z can be of that, right? So we can find steady state current around, no. You will not get that way. Surajit, you have to change your explanation. So here, this is going to be omega. Omega can be written as 100 radian per second. 100 radian per second. And one second. Timothy Amado, correct. What you said is correct. That is correct. I agree with that, right? So omega equal to 100 radian per second, and the input phase could be written as 45 degrees here. Clear? Now can you tell me what would be the impedance of this one all put together? Z equivalent. Z equivalent is R plus J into omega into L plus, once again it could be written otherwise, yes, J into omega L plus 1 by J omega C here, right? So all the values are there. So let me make it clearly here. Z equivalent is R plus J, you can take outside. It will become like omega L minus 1 by omega C. Correct? So this is considered as the impedance. Then may I know what is the modulus of the impedance here? Modulus of the impedance can be written as under root of R square plus omega L minus 1 divided by omega C whole square. Clear? So this is considered very good, 5 ampere option C. Excellent. So many students have given the answer. I am really very happy to see the answers from your side. However, let me take a few minutes of time to get it this, because there are so many students who don't know how to calculate this, right? So Z equivalent is this. Now we have all the values, isn't it? So we have the value like 3 ohm, and we have the value like L is equal to 0.08 Henry, right? And then we have C value which is equal to 0.04 farad or LC. All the values we can keep here to calculate the Z equivalent. Clear? Z equivalent. Now, how do we find the amplitude of the current? Simple. Amplitude of the current will be equal to the amplitude of the voltage, whatever we have here, that is equal to 25 here. So the amplitude of Z equivalent. Now, can anybody please help me in calculation and tell me what is the Z equivalent value? Tushar Karmakar, please let me know who has given the answer. Even Harsh also has given the answer. Harsh, please tell me what is Z equivalent here. I am waiting for your answer. Z equivalent का value कितना है इधर? Z equivalent is how much? So he got like 3 plus 4j. 3 plus 4j. Very good. Well, so if you keep all the way, maybe then if you have 3 plus 4j, then it must come the amplitude of Z is equal to 5, right? How Harsh you are getting 8.31? Yes. So you must calculate Z equivalent first. Get the value of Z equivalent, properly do it. Don't be in hurry burry, right? You have to be accurate. At the same time, you need to do properly also, right? So omega L, how much that will be? So 100, I could say, into 100 into 0.08. So it will be like 8, of course, minus 1 by omega c, right? So omega c, omega is 100 into c, 0.04. One by 4. Yes. So you very good, correct, Harsh, correct. You will be getting Z is equal to what is the value of Z here? The value of Z is equal to R, that is 3 plus then J into what you will going to get? J into any value. So I think it is 7.75. Proper, very good. 7.75. This is actually considered as your impedance here. Then now if you want to get the amplitude of the current alone, then what we need to do? Amplitude of the voltage divided by the amplitude of impedance we must calculate. Clear? So this is the way you must do. Now tell me, Harsh, how you got 5 ampere? How you got 5 ampere here? Are you getting 5 ampere for this? Yes. It's coming 3 ampere peak value, right? So it's coming 3 ampere peak value. So forget about the answers. Actually, you must be clear about your data, right? Because there are some students who are actually remembering and throwing the answer here. That's not good, right? So Z equivalent. First, find what is the Z equivalent here. So under root of, go back here once again. Yeah. So Harsh, if it is not there in the option, will you take that as a 5 ampere? That's not good, right? You need to calculate the actual answer, right? So 3 plus J into 7.75. Now the modulus of Z, how do we get that one? 3 square here plus, of course, it is going to be 7.75 square here. Then how much you will going to get all the way, right? So it's not like you, yes, Bhavana, very good. Z equivalent is equal to 8 point, how much that is? 8.31 ohm here. Then we can say I is equal to 25 divided by Z equivalent, which is equal to 8.31. Therefore, the current would be equal to, I think now it will come all the way around 3 ampere, right? So 25 divided by 8.31 approximately, it will come around 3. How many of you got 3 ampere? How many of you got 3 ampere current? That is correct answer. Even Tushkar has also done wrongly. See, it is not the question, because sometimes it happens, right? Even in the GATE exam also, you can find every year at least 1 or 2 questions will be wrong. I cannot say every year 100% there will be 1 or 2 questions wrong. It happens. I have seen, because from the last 12 to 13 years of experience, I have found almost around 3 to 4 years there was some mistakes in the GATE exam also. but it doesn't mean that when the options are not there, you will going to select whatever you want, right? So in that case, they will going to remove that question, or they will going to award 2 marks for every one of you. Clear? So 3 ampere is the correct answer. Good, good. Vetri, very good, very good. Bhavana, very good. No problem, Harsh. Keep trying on. And I sincerely thank for your participation. Now let's go to the next question. This is a wonderful question. Let me see how many of you can answer this question properly. So this is question number 20. So I think we are running out of the time. For the circuit shown in the figure, find the dVc of 0 plus by dt. Clear? Yes. Surijit, correct. You are right. Okay, Harsh, no problem. I think you have done it correctly only. I have 100% confidence on you. Surjit, your statement is correct. Now moving ahead to the next question. For the circuit shown in the figure, what is the value of dVc of 0 plus by dt? I will give some time. All of you try to think and solve this, because this is really a very good question and it is 2 marks question. It deserves to be a very great question. Okay, so how we can do this kind of questions? First of all, in these questions, first of all, you must see what is the status of the circuit from minus infinity to 0 minus. Look at that. What will going to happen? Minus infinity to t is equal to 0 minus. If you see this, and I am very confident, this current source will be open circuit here. Am I right or not? If this current source is open circuit, long time it is open circuit. If the current source is open circuit like this for long time, then it is the current source that will going to develop the current here, right? Suppose if I say all the way exactly at t is equal to 0 minus, exactly at t is equal to 0 minus, the inductor might be short circuited here. Inductor might be short circuited, and I am very sure the capacitor will be open circuit here. Capacitor will be open circuit, but that time as we have only 6 ampere current, all the way this 6 ampere will go in this way, 6 ampere will go in this way through the inductor here, correct? So therefore I can say the current through the inductor, especially at t is equal to 0 minus, which is also equal to IL of 0, and which must be equal to IL of 0 plus, that must be equal to how much? 6 ampere. Clear? Right? Harsh, no problem. I think 20 volt per second. Surjit, excellent. Very good. Very quick answer. Live view, right? So IL of 0 is equal to 6 ampere. Fine. That means the moment when we have, suppose look at this same question now, at t is equal to 0 plus we require, right? So at t is equal to 0 plus, how the circuit would be now? At t is equal to 0 plus, I can say clearly, now look at that, at t is equal to 0 plus, what is the way how the circuit looks like here? T is equal to 0 plus, we can say, yes, 4 ampere current will be there here. This is 4 ampere current. This will be again 4 ampere current here. And this must be 4 ampere current. Because at t is equal to 0 plus, we will be having u of 2 into the picture. Correct? Sir, minus 6. No, sir. Yes, that is all. Oh, so minus 6. Thank you. Minus 6. This side it is going. While I am speaking, I think I have told minus 6. But writing I have written 6, but it is minus 6. Thank you. So now at t is equal to 0 plus, this will be a 4 ampere current that will be coming all the way. Relax. 4 ampere is coming like this. If you want to calculate this dVc of 0 plus by dt, what you must calculate actually? You must calculate what is the current that is flowing through the capacitor. IC of 0 plus could be written as dVc of 0 plus C into IC of 0 plus can be calculated only when we know C into dVc of 0 plus divided by dt. That means if you know what is the value of the current, then we can find what is the value of the dVc of 0 plus by dt. So as I said, we require to calculate IC of 0 plus here, right? So now at t is equal to 0 plus, look at that. What is the current through the inductor? Current through the inductor. It is coming from the bottom like 6 amperes. So let me take that value also into the account. So at starting we will be having 6 ampere current here, right? It is the inductor which will go into allow 6 ampere current. Now use this value, all the way this current has to come like 6 ampere here, correct? 6 ampere here, 6 ampere here. Then what we want? 6 ampere it's coming, and 6 ampere it is going here, correct? 6 ampere it's going here. Now any one of you, have you calculated? Minus 20 volt per second, 20 volt per second, good. Then IC of 0 plus, if you see, all the way this current has to travel like this, right? So that means the total 4 ampere current has to travel through 1.1 by 5, sorry, this capacitor. Therefore I can say VC of 0 plus, sorry, the total current that is coming from the current source, all the way it has to travel through the capacitor. Why? Because this side the chain is broken. This 6 amperes has to go only like this, right? So the 6 amperes have to go like this, means effectively there is no current here. Effectively there is no current that should come. If it is 0 ampere, then only I can say whatever the 6 ampere that is coming here, all the way this 6 ampere will be rotating here, right or not? So the 6 ampere is rotating here, means there should not be any current through the resistor. If there is no current through the resistor 5 ohm, then the 4 ampere has to flow through the capacitor. 4 ampere has to flow through the capacitor, correct? So therefore, what should I say here now? Now I should say IC of 0 plus is equal to 4 ampere here, and IC of 0 plus is nothing but C into dVc of 0 plus divided by dt here, and of course that would be equal to 4. So C value we know. What is the value of C? 1 divided by 5, correct? So then I can move forward, and by saying like this, dVc of 0 plus divided by dt, that is equal to 20 volts per second. Therefore what would be the correct answer? Correct answer is option B. How many of you got this as a correct answer? Clear? So please respond in the comment section. Is it really a good question or not? All of you please tell me in the comment section, is it good question or not? How many of you enjoyed this question? I think the fastest, the person who has solved this for the first, very fast, that is Surajit. Is it good question? So here is the point. The initial current through the inductor, which is coming from the bottom, that 6 amperes, is continuously rotating in the same loop here. That means initially there is no current through the 5 ohm resistance. If you understand that right immediately, you can say that this 4 ampere is coming all the way through the capacitor. Finished. If you know that, then you can solve this question, right? So let's get into the next question here. Well, this question is the 21st question. Already for every question I have solved till the end. Now this question I will be leaving to you. So the Y parameter of a 2-port network is shown below. A 1 ohm resistor is connected to the network. Find the Y parameters of the circuit, or find the Y parameter of the network. Now you have all the way a matrix here. So let me say from the matrix that Y11 is equal to 5, right? And then Y12 is equal to 2. That is the second one. And then Y21 must be equal to 1. And then I can say Y22 is equal to 3. Clear? Y22 is equal to 3. Guys, are you following? Oh, I think you are, hurried to solve the question. So when the Y parameters are given to you, then my suggestion is convert this network, lower network, into a pi network. I feel that you know how to calculate pi network combination, especially when we are provided with the Y parameters, right? So calculate this here, calculate this all the way. So these values you must calculate for the very first thing. So calculate what is this, calculate what is this, calculate what is this. When you are provided with Y11, Y12 and Y21 and Y22. So the option A, very good, nice, very fast you, right? So then obviously we can say, right, so it is going to be 1 here and 1 dash here, right, 1 dash I would be saying, and then here it must be 2, and I would be saying that this is going to be 2 dash. So therefore from here, now from 1, obviously we need to calculate or re-evaluate that. From 1 to 2 there is 1 ohm resistance here. Clear? There is 1 ohm resistance. Very good, Tushkar, right? So now if you see 1 ohm resistance, what is happening physically? That these two are getting added here, correct? These two are getting added. When you understand that these two are getting added, because you know this value, now add that to 1 ohm, then you will going to get a new pi model. When we have a new pi model, then immediately convert that back to the admittance parameter. You will going to get option A as the answer for that. See, there are n number of ways to solve this question. My idea is I don't want to use so many formulas to evaluate the question. rather you need to be good with the basic. So what we have done, we have converted this Y parameters into a pi network. After that, this 1 ohm resistance is also added. Then it will going to become, because if you know what is this value, then combine this, then we will going to get a new pi model. And from that new pi model, we can re-access the required Y parameters, then option A will come as the answer. And instead of doing this, as I said, there are n number of ways, and some people who are using the direct methods, you will going to get the answer. But my method is always basic. Clear? So with this, I have completed circuit theory questions. All the way we have solved so far 3 1-mark questions. So I think 3 1-mark questions we have solved in the circuit 3 questions of 1 mark. So that is 3 marks, and 1 mark 3 questions, and 2 marks also we have solved 3 questions. All the way this is also equal to how much? 2 into 3, that is equal to 6 marks. So all put together 9 marks. So this is really a good weightage. It seems to be a very decent weightage, because 9 marks from circuit theory, obviously you can expect being a AC student. Now let's move on to the next subject, that is control system. Guys, let me know, are you energetic or not? So I think I moved little bit fast, because anyway I took only 35 minutes to solve the entire circuit theory question. Now I need your cooperation, I need your energy, and I need your momentum also. So then we can be in the resonance. So shall we go to the first question of the control system? Please respond in the comment section. First question of the control system. Everyone. Tushar and Dinesh, Prashant and Surjit. Well, Bhavana is ready, right? Question number 1. I want the answer very fast, within 1 minute. Please read the statement of the question and answer to me. Everyone, fast. The value of x5 divided by x1 for the signal graph shown below is dash. Fast. So how many forward paths are there? Look at the statement of the question clearly. So the number of forward paths, we can say there are 2 forward paths. Forward path 1 gain 1 into 2 into 3 into 4. So 2 3s are 6, 6 4s are 24. Fatafat. And then P2. What is P2 here? 1 into 5 into 4. Of course, this is going to be 20. Correct? So then what is the delta? In fact, loop 1, L1 is going to be how much? Loop 1 is the self loop. I can say this is the having the gain of 5. And loop 2 here, you all can see this is loop 2. This is the loop 2. All the way it is coming like this, coming like this. 3 into 4, 12 into 3, 36, minus is there, so therefore minus 36 here. Any answer? Sir, sir, given is not reciprocal network. How to make pi network? Who see, if it is not given that, right? So whether it is given or not, you can actually develop a pi model for that. So if you want the proof, you can actually contact me. I will show you the result. You can make it, no problem. Because if you want the proof, of course, it will take a lot of time. Even then we can make it. Whether it is a reciprocal or not, that really doesn't matter. Take this as a y11, or take this as a ya, and take this as a yb, and take this as a yc. Clear? Take this as a ya and yb and yc, and evaluate the y parameters for ya for this network. Then once you evaluate the y parameters for this, then equate that to this matrix. Then you will going to get ya and yb and yc. Simple. That is how even Surjit has also done, right? So I hope you got my point, Dinesh. Am I right? Dinesh got the point or not? Please let me know in the comment section. So L1 and L2, both we know what is the value of delta now. Delta value will be equal to 1 minus, so minus 36 plus 5. So all the way how much it will be equal to? 1 plus 31, which is equal to 32 here. Clear? Yes, yes. Okay, Dinesh. Thank you very much. So P1 is known to you, P2 is known to you, L1, L2, everything is known to you. And you require to calculate delta 1 also. Delta 1 is 1 minus sum of individual loop gains which are not touching the forward path 1. No loop is touching the forward path 1 here. So every loop is touching the forward path 1. So we don't have any loop like this. So delta 1 is equal to 1, and delta 2 is also equal to 1 minus 0, which is equal to 1. Then use all these things. Then what is your transfer function here? So x5 divided by x1, all put together, I could say P1 delta 1 plus P2 delta 2 whole divided by delta here, right? So moving ahead, what you will going to get? 24 plus 20 divided by delta value. How much is the delta value? That is going to be 32. So what is the final value? Surjit has given the answer. Bhavana wrong answer. Tushar correct. Tushar, correct? 1.375. Finished. So this is a simple question. You might have done it very fast. Bhavana, please check where you have done mistake. It happens, no problem. Sometimes everybody will do the mistake, right? Nobody is like Einstein, or even Einstein also will do the mistakes, right? So we have to accept each other and move forward. So no problem, Bhavana. Next time you make it accurate calculation. But as far as you are going near to the examination, your accuracy and speed both are very, very important. Trust me, even in a simple question, which is very, very simple, if you do the mistake and you will get regret, in fact, you will regret about that solution next 1 year, not next 1 year, lifelong. Instead of getting into IIT, you will go to NIT. One simple question can change your life. That's why you must be very accurate with your solution. No problem, Bhavana, it will happen, no problem. Okay, right. So next question, for the steady state, this is also a good question. For the system shown below, the total steady state error due to unit step disturbance due to unit step disturbance is, let us do one thing, let us not go with the input. Okay, let us not go with the input, let us calculate with the disturbance, then the question will be very interesting, and in fact it's beautiful also. Clear? So that means you have applied only disturbance. Generally, what is the steady state error? Steady state error can be written as E of infinity. Let me write down steady state error. See, I am giving a beautiful question, because if you want to take for unit step input disturbance, then time may be more, or it may take more time. That's why I am going only with the unit step disturbance. E of infinity could be written generally as equal to limit s tends to 0, s into R of s minus C of s. Clear? R of s minus E of s. For time being, let's consider that we are not applying input. So let us assume that for time being, let us say that we are not applying any input. So if we take input is equal to 0, that's fine. I don't want to make it so complicated, because I know every one of you are very clear and very clever to solve the question if the step input is given. But I want to see your analysis for, step disturbance here. Clear? Step disturbance. So therefore, what can I say? When the input is 0, yes, R of s would be equal to 0. Then I can say the steady state error E of infinity will be equal to limit s tends to 0 minus will be there s into C of s. In fact, I could say this is nothing but the final value of the output. Final value of the output. Then you may ask a question to me, sir, when we make clearly here, so please see, when we make the input is equal to 0, how do we get the output? When we make input is equal to 0, how do we make output? Clear? So we can get the output because of the disturbance. Clear? We can get the output because of the disturbance. That means C of s will be there because of the disturbance, right? But I told you that right now don't consider the input. Even if you consider input step as a input and do that, that is up to you. But I am asking that please go with the step disturbance. Any answer? Any answer? Very good, Surjit. Right? So step input minus 4.4. How do we find that? First of all, go with the C of s here. So if it is C, what should I say here? It would be C, and I can say this is also C, and this is going to be minus C here. And what would be the value here? Minus C divided by s plus 5. And what is the value here now? So I can say minus C divided by s plus 5 and plus D. This is the value that you will going to have here, correct? Then what is the final value of C? The final value of C can be written as, let me write this as equation 1 here. So now the final value of C can be written as equal to 100 divided by s plus 2, 100 divided by s plus 2 whole into D and minus C divided by s plus 5 here. Clear? S plus 5. Therefore, I can say all the way C could be taken outside. 1 plus 100 divided by s plus 2 into s plus 5. What should I write on the right side? 100 divided by s plus 2 into D, right? So therefore, if we go one more step ahead, what else we can say? C by D. Directly I am writing here C by D, which is nothing but C of s by D of s. That would be equal to how much? S plus 2 will get cancelled here, correct? So in fact, I could say all put together this will be s plus 2 into s plus 5 plus 100 here. That should be divided by s plus 5 here. and right hand side you will be having like 100 into d here. Clear? 100 into d. Therefore, what can I say? Here it will become 100 into s plus 5 whole divided by, what else you will going to have in the denominator? S plus 2 into s plus 5, of course plus 100 will be there. Then C of s can be written as equal to d of s all the way into this overall story here, 100 into s plus 5 whole divided by s plus 2 into s plus 5 plus 100. This is your C of s. Correct? Very good Aish Gupta, excellent. Very good, and Tushkar, very good. You people are gem. You are doing very fast. Then the steady state error, if I want to calculate, that could be given as minus limit s tends to 0 s into C of s. Now it could be written as minus limit s tends to 0 s into d of s is 1 by s, he has given in the question, into 100 into s plus 5 whole divided by, I could say s plus 2 into s plus 5 plus 100. Now just substitute s is equal to 0. If you cancel this, then you will going to get e of infinity all the way equal to how much? So it will come, I think, minus 500 divided by 110. All the way you will going to get how much? Minus 4.54. How many of you got minus 4.54? I am seeing the answer only from Tushar and Aish and Surajit. And those students who can solve the calculation later, no problem. Don't worry about that. But I feel what is important is the concept. That means when we apply the disturbance and when we don't apply the input, then this is the formula we must write. Clear? That means every time the steady state error is same, whether the input is present or not. That is only important. Clear? Now let's move ahead. Very good Harsha, right? Harsh. Very good Harsh. Well, let's go to the next question. This question, let me see how many of you will solve fast. This is from compensator. The transfer function of a compensator T of s is equal to this. That will provide the phase lead of 45 degrees and gain of 10 dB at omega is equal to 5 radian per second. Clear? So whenever you have this question, what you must do, don't go with any formulas. So T of s can be written as Kc into alpha into 1 plus j into omega into t whole divided by 1 plus j into alpha into omega into t here. Clear? J omega t and here j omega alpha t. Correct? Alpha t. Fine. Then can you please tell me what would be the magnitude or what would be the phase of this one? Both we need to calculate, isn't it? So both we need to calculate. Let me say t of j omega. So if you go for the phase calculation, any one of you? Phase of tj of j omega. What is the phase? This is the constant value. It doesn't participate in the phase. Now I am expecting the answer. Who will going to give the answer very fast for this question? Who will give the answer fast? Fastest person for this question. Let's see. Okay, Kc into alpha will not participate in the phase, and when we find the phase of this, it will come like tan inverse of omega t minus tan inverse of alpha into omega into t. Clear? Alpha into omega into t. That will be there. And he is saying that at omega is equal to 8 radian per second. 8 radian per second. Look at the statement of the question. When omega is equal to 8 radian per second, what must happen? So the phase must be equal to 45 degrees, correct? So that means at this frequency, I could say that tan inverse of 8t minus tan inverse of alpha into 8t. So 8 alpha t. Clear? That must be equal to 45 degrees here. Clear? That must be equal to 45 degrees. Now apply tan on both sides. What happens, Surjit? I expected that you will give the fastest answer. I am not seeing your answer and I am not seeing the answer from anyone. Do you feel that this is really a tough question? It's simple, right? So apply tan on both sides. When you apply tan on both sides, right side and left side, when we apply tan on both sides, then we can apply the formula like tan of tan inverse A. In fact, tan A minus tan B. So tan A minus tan B could be written at the end as 8t minus 8 into alpha t divided by 1 plus 8t into 8 alpha t. Clear? That is what you will be having. 8t and 8 alpha t. So this would be equal to right hand side tan of 45, that will become 1. Clear? Right side tan of alpha, tan 45, that will become 1. I have not done anything. For this simple equation, both the sides I have applied the tan. When we apply tan, then it looks like tan A minus B. So tan A minus tan B divided by 1 plus tan A tan B. That formula if I rewrite, right hand side we have tan 45 which is equal to 1. Till now I didn't get the answer. It's very easy, right? What you can do is, let us substitute the pair of options here. And if you are clever enough, you can substitute A and C, these options, in this particular value and check whether you are going to get 1 or not. If you substitute, I am very sure that will bring the value as 1 here. Clear? So that means this pair can satisfy the answer. That is the meaning of this. This pair, that is T and alpha, can satisfy the answer. Now how do we get the value of Kc? Clear? So you require the value of Kc also. Where is the Kc here? This is Kc. How do we get the Kc value? If you want to get the Kc value, then we need to find the magnitude of this one. So magnitude of this could be written as equal to, so look at that, Kc into alpha, as usual it will be there, Kc into alpha, however 1 plus under root of 1 plus omega t square, omega t whole square, whole divided by under root of, what else will be there here, 1 plus alpha omega t whole square, correct, omega t whole square. Then magnitude in dB, how do you write magnitude in dB? Magnitude in dB is equal to 20 logarithmic of this whole value whatever we are having here, Kc into alpha under root of 1 plus omega t whole square here divided by under root of 1 plus alpha into omega t whole square, and this must be equal to 10 dB. Clear? This must be equal to 10 dB. Harsh is saying unit gain. Okay, fine. Harsh is saying unit gain. So now this has to be equal. Already we know the value of omega. What is the value of omega? 8. And what is the value of t? T already we know the pair which going to satisfy here is 0.3018. And what else we know? We know the value of alpha also, that is alpha is equal to 0.1715. We know all these three values. Just put all these values in this particular expression and calculate the value of Kc, and once you get the value of Kc, check the option. In case if we get Kc is equal to 7.6366, then you can select that answer. If you are not getting that, then A and C will be the answer for that, right? A, B, C, Surjit is saying A, B, C, right? So that means A is the correct answer, B is the correct answer, and C is the correct answer. That was given by Surjit. But I want to give this as a homework to you, because 99.9% of the question I have done it, and remaining you need to do, right? So option D is not correct. See, above all options are not correct. That is given here. So this is wrong, because we are seeing that option A and option C 100% that is correct. Option A and option C 100% that is correct. So therefore, you must actually look at whether option B is correct or not. That you have to calculate from here, because I have done 99.9% of the time, right? Yes, very good. So if you do this, then Kc value will come like, that is 7.636. So therefore I can say all option A, B, C are correct. Very good, Bhavna. Very good, Surjit. Very good. So this is a good question, right? So you need to work out all the things which are related to compensators. Now let's move on to the next question. Next question is this. Question number 25. Question number 25. Look at this question. The open loop transfer function of a feedback control system is G of S into H of S is equal to -1 divided by 2S into 1 minus 20S. Clear? 1 minus 20S. Then what is the Nyquist plot for this particular diagram? Clear? How do we write the Nyquist plot? That is a question. So whenever you get this one, I sincerely say that for every open loop transfer function, please evaluate the phase first. G of j omega into H of j omega I could say, which is equal to -1 plus j0 here, and then I can say 2 into j omega here, and then again 1 minus j into 20 omega here. Clear? How do we write the phase of this one now? Now phase could be written as equal to, phase is equal to phase of this system, that is G of j omega into H of j omega. Any answer from your side? Look at the statement of the question once again. All of you please take the snapshot of this and let me know what is going to be the correct answer for this question, and I will be waiting for your answer seriously. So the phase could be written as -1 plus J0. What can I write? So this is going to be 180 degrees or minus 180 degrees we are going to write, right? So anyway, we are calculating the anti-clockwise phase. So this would be like 180 degrees minus j omega is there in the denominator, that is going to add 90 degrees here. Fine. And then minus, what would be the phase of this one now? Can you tell me what is the phase of this one? Phase of this particular complex number, I am taking 180 degrees. Hope you are getting this point. Phase of this complex number I have taken as 180 degrees here. Now the most important thing is, yes, this is going to be 180 degrees. And what is the phase of this one? So x is positive, y is negative. So it will become like minus tan inverse of 20 omega here. So all put together, I am very sure it will come like 90 degrees plus tan inverse of 20 omega here. 90 degrees plus tan inverse of omega. That is going to be your phase. Clear? That is going to be your phase. Sir, can you show the options? Very good. So please see the option here. So anyway, I need to show the options here. So the phase, after a lot of hard work, we understood that the phase is equal to 90 degrees plus tan inverse of 20 omega here. Now I sincerely request keep omega and keep the trace of phase here. When you keep omega is equal to 0, can you tell me what will happen? When you keep omega is equal to 0, you will going to have 90 degrees here. Let us keep omega is equal to 1 by 20 if you want. 1 by 20. 1 by 20 if you keep 90 plus tan inverse of 1. So it will become like 135 degrees here. And if you keep infinity, omega is equal to infinity, then it will become tan inverse of infinity. 90 plus 90. All the way how much you will going to get? 180 degrees you must get. Clear? So that means when omega is changing from 0 to infinity, the phase must change from 90 degrees to 180 degrees. Phase must change from 90 degrees to 180 degrees. Very good. That is clearly happening only in option B. Clear? So option B, if you see, at starting it might be phase really equal to 90 degrees. So after that it is 135, 140, 150 and then finally it is tracing to the 180. This is happening only in option B. Therefore I can say option B is the correct answer. Is it good question or not? How many of you enjoyed this question? In fact, in this particular question, calculating the phase is a crucial point. Most of the students, they don't know how to calculate the phase properly. If you don't know how to calculate the phase properly, then you will do the mistake. Clear? So this is a good question or not? How many of you like this question? Previous question. How many of you liked this question? I want to know from your side. Dinesh and Tushar and Ayush and Bhavana. Ayush, if please check your phase. Option D could not be the answer. Why? Option D is saying that at omega is equal to infinity, the phase. However, the magnitude is also important. You need to trace the magnitude also. Clear? So if you look at only phase and magnitude, yes, very good question. So if you see phase only, then either option B or option D. These are the two things you will get confusion. Then look at the magnitude. When you find the magnitude of this function, can you find the magnitude of this? Modulus of g of j omega into h of j omega. When you find the magnitude of this, it will come like 1 divided by omega, 2 omega into under root of 1 plus. So 20 omega whole square. This clearly says that at omega is equal to infinity, magnitude must be equal to 0. Correct? Magnitude must be equal to 0. Where it is possible here? So that is possible when omega is equal to infinity, the magnitude should be equal to 0. That's possible only with the option B. Clear? So yes, Surajit. Yes. That's what I'm doing. That's what I'm saying. Surajit, you are also right. Yes. Pole at 0 now. So easily we can say, because when we have pole at 0, obviously at omega is equal to infinity, the magnitude will be 0. Directly we can see and let the answer to go. Option B is the correct answer for this. Now look at this 26th question. How many questions more are there? Yes. I think we are last but one question. The root locus of a unity feedback system is shown below. The point at which the root locus diagram crosses the imaginary axis is dash. Clear? The point at which the root locus will cross the imaginary axis is dash. So it's simple. First of all, for this kind of questions, get the value of g of s into h of s. So g of s into h of s, if you see, See, there is a pole here, correct? There is a pole. So therefore I could write down this as we can take like k here divided by s plus 4, first thing, and then there should be two more poles here. Why? Because the root locus is living from these poles, right? So it is -1 here and it is j. So that means another pole, one pole we have seen that is equal to -4, and the second pole is -1 plus j here, -1 plus j, and the third pole would be equal to -1 minus j here. So therefore this combination, how can I write this one? This will be s plus 1 whole square plus 1, if I am not wrong, right? So s plus 1 whole square plus 1, then it will become like s plus 1 whole square is equal to -1. Yes, this is perfectly all right, correct? So therefore we have clearly like k divided by s plus 4 into s plus 1 whole square plus 1. Now he is asking that at what value of what is the imaginary crossover frequency? That means what we need to do, first of all calculate the characteristic equation. How do we calculate characteristic equation? 1 plus j of s into h of s is equal to 0. So therefore already we have this value 1 plus, look at that, k divided by s plus 4 whole into s square. One second, it will become like s plus 1 whole square plus 1, correct? So that must be equal to 0. Therefore moving ahead I can say that is s plus 4 whole into s plus 1, right? S plus 1 whole square plus 1 plus k, this must be equal to 0. Then convert this into a beautiful characteristic equation. Very good guys, excellent, right? Very good, nice. So convert this into characteristic equation and then replace s is equal to j omega, and then real part and imaginary part both you make it to 0. Then evaluate the value of k at which your root locus cuts the j omega axis. At the same value of k, try to catch the value of omega also. And already you have given the answers very fast compared to me. So let me go with the option A, which is the answer for that. And you can even use the phase criteria also if you want. Clear? You can even use the phase criteria and select whether that is correct or not, because if you use phase criterion, first option itself you will going to get the correct answer. Clear? So let's quickly go to the next question here, right? So 27th, the state variable formulation of a system is given like this lengthy expression here. Well, x1 dot, x2 dot, everything is properly mentioned. The beauty of this question is we have a eigenvalues here. Clear? We have a eigenvalue -2 and 1, and especially x1 0, x2 0, it's given as 0. What does it mean? The initial state variables, that is x1 of 0 and x2 of 0, both are actually mentioned as how much? It is equal to 0 and 0 here. Clear? So all of you please try to work out fast. I am waiting for your answer. Every one of you please be fast and try to solve and let me know what is the answer for this question, because so far I have solved number of questions. In fact, each and every question I have solved in. Now it's the time you need to work out and tell me what is the correct answer for this. Let me call to Sanjay Rathi Sir, who will going to handle the session right immediately after my session, EDC as well as analog electronics. Hello. Right, 2 minutes. Right guys, any answer from your side? Of course I know it may take little bit time, but no problem. I will wait for 1 or 2 minutes. Please try to make it fast. How do we solve this question? To solve this question, first of all you must know how do we evaluate the transfer function. First evaluate the transfer function. So the transfer function could be written simply as it is equal to C into first of all find the transfer function. Step number 1, transfer function, which is equal to C into Si minus A whole inverse into B. Calculate this and find the transfer function. You will going to get the transfer function as y of s divided by u of s. Of course, you will going to get a matrix here, right? So after getting that, then you can make it simply like whatever you get here, take that one, and then y of s could be taken as u of s into whatever you got here, just multiply that and then take the inverse Laplace of this. Y of t can be written as L inverse of y of s here. Clear? That's it. This is the procedure. Let me see who will going to make it this fast. So last question you said about phase criteria. Explain shortly about that. Oh Dinesh, I am extremely sorry Dinesh, actually. So the time already I have moved it very fast. It's very simple. Phase criteria or magnitude criteria. Please go to the recorded lectures. If you have BYJU'S Exam Prep app, there is a list of lectures which are available in root locus. Just go through the root locus and whatever the topic is there, phase criteria and magnitude criteria, go there, you will going to get it. Maximum 5 minutes it will going to take. Not maximum 5 minutes, of course it will take 10 to 15 minutes. Go through the entire lecture, you will understand that, right? Because almost around another 4 faculties has to take the session. I'm extremely sorry. In case if you are not getting the answer, I sincerely suggest reach to me on this number. Clear? So please reach on this number. I will be helping you. Right. So what would be the correct answer? So many students have given the answer. Very good, Aish Gupta. And of course, this is the procedure you must follow. And if you follow this procedure, then you will going to get option A, which is the correct answer for this question. Well, we have done with the circuit theory as well as control system. Hope you really enjoyed with this. Please let me know in the comment section how many of you really enjoyed the session on circuit theory and control system. To be honestly, I have not given any questions which are far beyond the gate level. I have not given any question below the gate standard. So I have actually given the questions on the equal to gate standard so that you will really face the feel of the gate examination. Hope you really enjoyed with the session of on control system as well as circuit theory. And next live will be taken by Sanjay Rathi Sir. He will going to handle both analog electronics as well as EDC together. And as I said, those people who are having any doubts on circuit theory and control system, I have provided my number. You can reach out to me whenever you want or whenever you have questions. Till then, take care. Bye bye. Sanjay Rathi Sir will going to handle the session from now onwards. Clear? Right.
Okay. Hello everyone, very good afternoon and welcome to the BYJU'S Exam Prep. This is Sanjay Rathi. Now I will discuss the questions from electronic devices and circuit and analog. Okay guys, and try to give the answer for all the questions. Right, ready with rough pages and virtual calculator. Okay guys, because we are going to solve number of important numericals from electronic devices and circuit. And since it is a mock test, then try to give the answer for all these questions. Okay, without any delay, now that is my small introduction. Myself Sanjay Rathi, and I am having around 21 plus years of teaching experience, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008. And during my teaching, I have mentored more than 1 lakh students for GATE, Engineering Services Exam, ISRO, DRDO, BARC and other PSUs. Okay guys, and according to my experience, now this is the time for quick revision and for mock test. So you will get the idea about important topics and important numericals from EDC and analog. Now the first question on your screen, that is, silicon is doped with boron to a concentration of 5 into 10 to the power 17 atoms. Right, that is the question from electronic devices and circuit. First question, semiconductor physics. This is very important topic. Now, silicon is doped with boron to a concentration of 5 into 10 to the power 17 atoms per centimeter cube. Assume the intrinsic carrier concentration of silicon be 1.5 into 10 raised to power 10, that is the standard value, and the value of kT by Q, that is called VT, volt equivalent of temperature, is 26 millivolt at 300 degree Kelvin, then compared to the undoped silicon, the Fermi level of doped silicon goes down by. What is the answer? This is the numerical answer type question, right? And sorry, here MCQ, multiple select question, option A, option B, option C, or none of this. 1 mark only, right? Try to give me the answer then. And please share the link of this session, like the session and subscribe our channel. Okay, हम लोग रेगुलर इंटरवल पर ये अरेंज करते रहेंगे, दैट इज द मॉक टेस्ट, सो दैट यू विल गेट द आइडिया, right? And you will get the idea about what? Your strength and weakness. Okay guys, now please, what is the answer for this question? Okay Surjit, you have given that 0.45. Now it is a silicon simply doped with boron. First, what is boron? Boron is a trivalent. Boron is what? Trivalent. And when we are giving the trivalent impurity, means acceptor impurity. Acceptor impurity means simply this will goes downward. So this, that is written in the question, that is goes downward. Yes, this is EC, this is EV, and now that is EFI. So actual Fermi level will lie here. EV, that is the Fermi level. Now this goes down, and what is the formula for this? Standard formula, KT log of Na by Ni. Very simple, KT log of Na by Ni. Now when I am putting the KT is given in the question, that is 26 millivolt at 300 degree Kelvin. It will become 0.026 electron volt. Log of Na is given in the question 5 into 10 to the power 17, 5 into 10 to the power 17, and that is the standard value 1.5 into 10 raised to power 10. You have to take the natural log, use your virtual calculator, and you will get the answer. That is what? 0.45. B is the correct answer for this question, 0.45. Next one, next question. Now this is a very important on what? Reverse saturation current. What is the effect of the temperature on the reverse saturation current? What is the theoretical value and what is the practical value? Okay, now please try to solve this question. It is predicted that for germanium the reverse saturation current should increase by 0.11 per degree centigrade. That fraction is given. 0.11 per degree centigrade, that fraction is given. It is found experimentally in a particular diode that at a reverse voltage of 10 volt, the reverse current is 5 milliampere. Now the reverse current is 5 milliampere. The temperature dependence is only 0.0 per degree centigrade. So that is the fractional. This is the practical value and that is the theoretical value. The value of the leakage resistance shunting the diode is. This is a numerical answer type question, 2 marks question. Everyone try to give me the answer for this one. Yes, Bhavna, your answer is correct. Tushar, your answer is correct. Dinesh, so number of students are attending the session. Nachiket, Dinesh, Bhavna, Tushar, Ayush, Surjit, and please send the link right to your friends so that they will join, and definitely try to solve all the questions. Okay, it is predicted that for germanium, okay, this 0.11 per degree centigrade means this is the change in reverse saturation current, that is called fractional change. Let I naught is the reverse saturation current. I naught is the reverse saturation current ideally, you और बोलते हैं theoretically. Okay, that is what we can say, it is a theoretical current. Now what is the fractional change? d I naught by I naught dt. That is given as, or sometimes it is written like this, dt. This is 0.11 per degree centigrade. Or if it is written in percentage, di naught by dt, it will become 11% per degree centigrade. 11% per degree centigrade. It is found experimentally in a particular diode that reverse voltage of, at the reverse voltage of 10 volt, the reverse current is 5 milliampere. We are getting the actual reverse current as 5 milliampere, and the temperature dependence is only 0.07. This is the practical reverse saturation current. And what is the temperature dependent? That is given as 0.07 per degree centigrade. Okay, so what is the answer for this question, everyone? 5.495 Surjit. Okay, तो चलिए देखते हैं. Now in this question, yes, if this is the diode, when we are making it practical, this diode is reverse biased by using the 10 volt. Now actually we are calculating this current in reverse direction. Now every diode has some leakage current. Remember, this is a question from the devices. So every diode has some leakage current, and that is called surface leakage current, and that is represented by a resistance parallel to the diode. A resistance parallel to the diode, that is called surface leakage resistance. Now this current I, this is a practical current. It is divided into two parts. One current will flow through this, that is the junction, PN junction, that is called I naught, and one current will flow through this, that is called leakage current, surface leakage current. The total current will become I naught plus IL. This is the surface leakage current, that is given as 5 milliampere. 5 milliampere. Second thing, if you want, we have to find the R, value of R, that is written here. The value of leakage resistance shunting the diode is. So value of leakage resistance, how we are going to find this leakage resistance? This is the leakage resistance or surface leakage resistance. This 10 volt is given. These two are connected in parallel. If suppose we are having the value of IL, we can find the RS. So RS is nothing but 10 divided by IL. How we can find the value? Now, this is given. We are not having the value of I naught. So if once we will get the value of I naught, we can find the value of IL. Now, differentiate it with respect to temperature. It will become di by dt. That is equal to di naught by dt. And leakage current is independent of temperature. That is 0. Means this is the equation number 3. di by dt is exactly equal to di naught by dt. Then we have this value di by dt 1 by I and di naught by dt. These are the two values. di by dt 1 by I is equal to 0.11. 1 by I naught di naught by dt. This is given as 0.11 or this is given as 0.07. 11. Now this is the equation number 4. Equation number 5. Divide 5 by 4. Right? Or we can divide 4 by 5 simply. 4 divided by 5 equations. Then it will become I naught upon I. I naught upon I is equal to 0.07 divided by 0.11, that is nothing but 7 by 11. So what is the I naught is equal to 7 by 11 times of I. 7 by 11 times of I. Now you can find the value of what? Reverse saturation current. Theoretical. 7 by 11 into 5, that is nothing but 35 by 11. So this is in what is the current given? 5 milliampere, right? Reverse current, it is a 5 milli. Right, chaliye. 1 minute. This is the microampere. Sorry, this is the printing mistake because the reverse saturation current will be in microampere. No problem, this is in microampere. Correct it. Now it will become microampere. So So what is the leakage current? Leakage current will become 5 minus I naught. 5 minus 35 by 11. And that is nothing but 55 minus 35 by 11. That will become 20 by 11 microampere. Once you will get the IL, you can find the value of the resistance. What is the resistance? 10 divided by IL. Resistance 10 divided by IL. And that will become 110 divided by 20. That is 5.5 mega ohm. Because this is current is in microampere, and that's why the resistance will be in what? Mega ohm. So 5.5. So remember, always remember that reverse saturation current will be in what? Microampere. This is the microampere. That was the printing mistake, but that is the formula. Okay. So that is the question from what? PN junction. This type of questions you have to solve, right? No doubt. After solving the previous year question, get the idea about what will be the change in the question, what will be the next on the standard diagram. That is the method. You can anticipate the question. Which type of question in GATE 2023. Okay guys, next one. 5.5 mega ohm is the answer for this one. Now tell me, very simple one, 1 mark question only, MCQ, 1 mark. This is a figure. Normally different types of capacitance, that is what CV characteristics, capacitor voltage characteristics, that is the important topic, accumulation mode, inversion mode, depletion mode. But there is another type of capacitance, that is called source body junction capacitance, drain body junction capacitance, capacitance in triode region, capacitance in what saturation region, overlap capacitance. So these all are the important topic. Get the idea about all these. Everyone focusing on what? CV characteristics, but that is also important. In the three-dimensional view of the silicon N-channel MOS transistor shown below, del is the 20 nanometer. The transistor is of width formed at every PN junction is 10 nanometer. The transistor is of width formed at every PN junction is what? 10 nanometer, right? And that is talking about the right space charge region. That is the space charge region in every junction. The relative permittivities of the silicon are given 11.7 and 3.9. Epsilon naught is given as this much. The gate source overlap capacitance is approximately. It is talking about the overlap capacitance. Overlap capacitance. Okay, what is the answer? To overlap capacitance, that is given, epsilon naught is given, this value is given, and the figure is given. So what is the overlap capacitance? This is the diagram. This is the two-dimensional view. Metal and semiconductor. And that is the overlapping. Overlapping of SiO2 over what? N positive area. Source and drain. And this is called del. Overlap length. This is del. And this is the oxide width. What is the oxide width given here? From the diagram you can judge 1 nanometer. That is the given 1 nanometer is the TOX. 1 nanometer width of the SiO2 layer. This is the SiO2 layer. This is N positive. This is N positive. And this is the overlap length here. Okay. Now, what is the oxide capacitance per unit area? First of all, you have to find the oxide capacitance per unit area. Second thing, you have to find the area of this region. This is the value. This is the three-dimensional figure. Right. Now, that is the width. W, and this is the overlap length. So my dear friend, what is the width, what is the area of this strip? Area of this strip we can find like this. Okay, what is the area of this portion? The area of this portion is W into what? Del. Once you will get the area of this portion, that is the overlap area, then we can find the capacitance. What is the capacitance? Area into what? Capacitance per unit area. That will become overlap capacitance, and this is nothing but overlap area. Okay, so overlap area is given by W into del. W means this width. So what is the width given? 1 micrometer, that width is given. 1 micrometer, that width is given. What is the del is given? This is the del. What is the del in the question? 20 nanometer is given. Then you can find the area, and you have to find what? Oxide capacitance per unit area. To get the oxide capacitance per unit area, epsilon naught x by TOX. Epsilon naught x is 3.9 into epsilon naught upon TOX. Now, what is the epsilon naught? 8.9 into 10 raised to power minus 12 farad per meter is given, and epsilon r is 3.9 for SiO2. So 3.9 into 8.9 into 10 raised to power minus 12 upon TOX. Use this TOX, 1 nanometer. 1 nanometer means what? 10 raised to power minus 9 meter. Meter cancel, and you will get the value of COX. Once you will get the value of COX, then del into W into COX. Del into W into COX. So what is the del? Del is 20 nanometer. 20 into 10 raised to power minus 9 nanometer. Then what? W is 1 micrometer into 10 raised to power minus 6 into COX 3.9 into 10 raised to power minus 12 into 8.9 divided by 10 raised to power minus 9. Now you can calculate the value. Now you can calculate the value here. Okay, this is cancel out, this is cancel out, and so on, and you will get something into 10 raised to power minus 15 farad. 10 raised to power minus 7, 15 farad. That is, the answer is 0.7 into 10 raised to power minus 15 farad. But remember, 10 raised to power minus 15 means what? Femtofarad. 1 femtofarad is equal to 10 raised to power minus 15 farad. And that's why the answer is 0.7 FF. 0.7 FF. This is the overlap capacitance. Okay. Now, remember, yes, Surjit, your answer is correct. Tushar, your answer is correct. Option A, that is given by the Surdeep and Tushar. So, try to solve this type of questions. Now, with this question, remember, source body junction capacitance. This time that is important. Drain body junction capacitance, right? Capacitance in triode region and capacitance in saturation region. Right? Please get the command over this. No doubt, we have the idea about the CV characteristics, accumulation mode, depletion mode, and inversion mode. That is called CV characteristics. Okay. Chaliye. Next question. Next one. In the circuit shown below, assume that the voltage drop across a forward bias diode is 0.7 volt. Thermal voltage is given VT, 25 millivolt. KT by Q, that is VT, is given as 25 millivolt. The small signal input is VP cos omega t, where VP is 100 millivolt. It is a MCQ, multiple choice question. There is a negative marking. Remember, the AC output voltage is, AC output means a small signal voltage. What is the small signal output voltage for this diagram? For this diagram, there is a two output. One is DC, one is what? AC. There are two outputs. One is DC, one is AC. So what is the AC output of this diagram from the four options? A, B, C or what? D. Yes, that is a question from the diode. Right, we are connecting the four diodes in series. Okay, here it is a 9900 ohm resistor is connected here. Like this is R. This is the DC supply 12.7. This is the AC supply. And you have to find the AC output for this particular diagram. These are the four options. 0.25 cos omega t millivolt, 1 cos of omega t millivolt, 2 cos of omega t in millivolt, 22 cos of omega t in millivolt. Okay. And the Vp is given as 100 millivolt. Right. So थोड़े जो अनएक्सपेक्टेड क्वेश्चंस है ना, टॉपिक्स, वो निकाल कर जरूर सॉल्व कर लीजिएगा. यू विल गेट दिस टाइप ऑफ टॉपिक्स फ्रॉम व्हाट स्टैंडर्ड टेक्स्ट बुक, और यू कैन अटेंड रेगुलर मॉक टेस्ट, regular series on our channel. Definitely we will cover those topics. Okay, and everyone try to solve the previous year question minimum 10 to 15 years, right, so that you will get the idea. You will get the idea which type of questions they may ask. Okay, what is the answer? Now, four diodes are connected in series means, first of all, if you want the AC, then this is called small signal analysis. AC means this is called small signal analysis. In a small signal, for a small signal analysis, we have to find the dynamic resistance of the diode, that is called R. Dynamic resistance of diode. Once we will get the dynamic resistance, the diode is replaced by what? That resistance. That dynamic resistance is given by eta Vt by I. Eta Vt by I, where I is the current through the diode when the diode is forward biased. So once you will get the option B, Tushar is giving the option B, 1 cos of millivolt. Okay, I will check 1 cos of millivolt. Okay, 1 minute. Then eta Vt by I. Here, that is the characteristics of the diode. Once you will get the current for this portion, we have to find the slope. Slope means 1 by R, and that is called dynamic resistance. And for this portion, it behaves like what? Linear diode. Linear, it will show the linear characteristics. Otherwise, the diode is what? Non-linear. So to find the dynamic resistance, this is called DC current through the diode. First of all, DC analysis. In DC analysis, consider only DC portion. And when the diodes are on, it is replaced by 0.7 volt battery. All the diodes are on, and that's why all the diodes are replaced by 0.7 volt battery. Okay. So 0.7, 0.7, 0.7, 0.7, this is the 12.7, and this is the 9.9 kilo ohm. Now, you can find the current here. The current will become 12.7, this is the 0.7, 0.7, 0.7, 0.7, what is the value here? 2.8 volt. Output DC value is what? 2.8 volt. Once you will get 2.8 volt upon 9.9, and that current is what? 1 milliampere. Current is 1 milliampere. Okay. Now, what is written here? Voltage drop across a forward bias diode silicon. It is especially mentioned here silicon, that is 0.7 volt. The thermal voltage Vt. Now, what is the ideality factor for silicon? Ideality factor for silicon is 2. Vt, it is given in the question, 25 millivolt. Current is what? 1 milliampere. Milli cancel, and R is equal to 50 ohm. R is equal to what? 50 ohm. Once you will get the R, then all the resistors are replaced, all the diodes are replaced by R, and now we can consider the AC signal only. Then this is the AC signal, and all the diodes are replaced by resistance, dynamic resistance, and that will give you the AC output, and this is the AC input. So what is the AC output? According to voltage division rule, it will become 4R upon 4R plus capital R into input. So 4 into 50 divided by 4 into 50, that is nothing but 200 plus 9900 into what? What is the signal, AC signal? Vp cos omega t. What is the value of the AC? 100 millivolt. 100 millivolt, that is 100 cos of omega t. Remember, it is in millivolt. Now calculate. Everything is in ohm. Now tell me which answer is correct. तो आप देखेंगे, this is the 200 divided by, use your virtual calculator only, and you will get around 1.98. You will get around 1.98 cos omega t in millivolt. So 1.98 nearly equal to, okay. So which answer is correct? 1.98 means which is near to 1.98? C. C is the correct answer. 2 cos of omega t millivolt. Okay, that is the question on step star. What is the name of this diagram? Okay, Tushar, you have taken eta. What? Silicon is written here, right? Tushar, silicon is written here, and other thing that current is not, like especially silicon is mentioned here. When the especially silicon is mentioned here, second thing, what about the current? Current is not too high. Current is only 1 milliampere. If the current is too high, then again we can take eta is equal to what? 1. That is called ideality factor. Okay. The next one. Your approach is correct, but that's why it is especially mentioned in the question, silicon. Okay then. Now that is the, what is the name of this circuit? This is also called, during DC analysis, it will provide the constant voltage. What is the during DC analysis? What is the constant voltage across this? Once the diode is on, it will provide a constant voltage of 2.8 volt. If suppose it is a variable, doesn't matter. Because all the diodes are on, it will provide a constant voltage. We are getting the stabilized voltage at the output, that is 2.8 volt, and that's why it is called step star. Name of this diode. These diodes are connected in series. Okay, next one. Now question on what special diode, right? Last question from electronic devices and circuit, then we will start what? Analog. So tell me, consider a silicon PN junction at 300 degree Kelvin with the following parameter. Na is given. Na means acceptor doping is given. Nd means donor doping is given. Diffusion constant of electron is given. Diffusion constant of hole is given. Mean lifetime of electron is given. Mean lifetime of hole is given. Mean carrier lifetime is given. Consider the photocurrent density. Consider the photocurrent density is 15 milliampere per centimeter square. The open circuit voltage of the solar cell is, up to 2 decimal places you have to give the answer in volt. 2 decimal places in volt. Numerical answer type question, 2 marks question. Question on special diode, that is what? Solar cell. Okay. Tell me what will be the answer. Remember, for a GATE exam, please prepare the special diodes, means what? Zener diode, avalanche diode, photodiodes, photoconductor, right? And what? LED, laser, solar cell. Definitely there will be a straightforward question on that, and formula based question, 2 marks, right? So please, what is the answer? Now this data is given. Try to solve this question. This data is given. Take a screenshot. Na, Nd, Dn, Dp and so on. Open circuit voltage for solar cell is asked. So remember, for solar cell, What is the open circuit voltage VOC? Open circuit voltage is given by VT log of, right, 1 plus ZL by what? ZS. VT log of 1 plus ZL by ZS. This is the value. So what is the VT, volt equivalent of temperature? That is given in the question, right? Where it is given? I think 300 degree Kelvin is given. So you can find the VT. T by 11,600, or it is nearly equal to 300 divided by 11,600, that is KT by Q, right? You will get 0.0259 volt. This is the value of VT. NA given, ND given. Now next thing, what is the ZL? This is the, consider the photo current density, 15 milliampere per centimeter square, it is given. Then ZS. ZS is nothing but IS by A, or normally we are saying I naught by A. What is the I naught or IS? Reverse saturation current. Reverse saturation current. Reverse saturation current. Okay, so that is the formula. Now this is not given in the question, so we have to find the value of the JS from the given data. So what is the formula for the JS or current density? JS is given by reverse saturation current divided by A. And what is the formula for I naught? That is become AQ dP Pn naught upon what? LP plus AQ dN NP naught upon what? Ln. That is the formula for reverse saturation current, and that is divided by 1 by A. So A cancel, Q is common. Now what is the Pn naught? Minority carrier concentration, that is given by Ni square by what? Nd. This is in N side. Towards N side, what is the minority carrier concentration? Ni square by Nd. And Pn naught, Np naught now. Np naught is given by Ni square by Na. Ni square by Na. Nd is given in the question, Na is given in the question. This is Nd and Na. These two data are given in the question. Then we can use this formula. Put here A common, A cancel, Q common. Now it will become dP Ni square by Nd into Lp plus Q is already common, Dn Ni square by Na into what? Ln. Na into Ln. Remember that you have to give the minority carrier concentration. So minority carrier concentration we are writing Np naught by Ln or Na. Now you can take Ni square as a common, then it formula will become Js, that is nothing but Is upon A, is equal to A already cancel, Q Ni square intrinsic carrier concentration under bracket dP by Nd Lp plus Dn by Na Ln. Na into Ln. Now put the values. First of all, find the Lp. Lp is equal to root over dP tau p. Root over dP tau p. dP is given, tau p is given. 10 into 10 raised to power minus 7. 10 into 10 raised to power minus 7. Remember, tau p is given in second and dP is given in 10 centimeter square. 10 centimeter square, 10 raised to power minus 7. Get the value in centimeter. Get the value in centimeter. Right? So 10 to the power minus 6. Remember that this is the 10. I think this is the 10 to the power minus 6 and root ho jayega 10 to the power minus 3. Ln. Root over Dn tau n. That is, you can put the value here 25 and tau n 5 into 10 raised to power minus 7. Find the value in centimeter. Because it is a centimeter square per second, you will get this in centimeter. Once you will get the Lp and Ln, put the value of Nd, put the value of Ni. What is the Ni? Value of Ni. This is the silicon junction. If it is not given, Ni is not given, always use the standard value. That is what is the intrinsic carrier concentration, or it is represented as Ni. 1.5 into 10 raised to power 10 per centimeter cube. 1.5 into 10 raised to power 10 per centimeter cube. If you are saying that, sir, it is not given, to how we are going to solve? So remember, that is we are having the standard value. Okay, guys. So that is the calculation is your part. Calculation is your part. Then I will give the value, actually what you are going to get the value. Okay, please check this value, because we have to solve number of questions. So once you will solve, you will get around LP, that is ln 35 point minus 4 centimeter, or LP is 10 to the power minus 3 centimeter. Yes, we are going to get LP and ln. Put the value, and finally you will get the JS is equal to 3.6 into 10 raised to power 11. Check the value, and finally put the value Vt log of 1 plus ZL by Zs, and you are going to get the answer 0.514. Open circuit voltage 0.514 volt. Up to 2 decimal places means you can write 0.51. 0.51 we can write the answer here. Hope so that is clear to you. Next one. Next question. Okay, then analog electronics. तो यार अब कहाँ जा रहे हो आप लोग? आ जाइए प्लीज. अब we will solve some questions from the analog electronics. Okay, guys. So that is the question from EDC. Then first question from analog electronics. From common emitter with what unbypassed RE? That is the most important topic from amplifier. The common emitter amplifier has an unbypassed emitter resistance of 1 kilo ohm. Unbypassed emitter resistance of 1 kilo ohm and a collector load of 6 kilo ohm. Means first of all, make proper diagram for this. Unbypassed emitter resistance RE, that is given 1 kilo ohm. RC, that is called load resistance. It is given as 6 kilo ohm. Beta, that beta is given as 100. And this is given as IC is equal to 1 milliampere. Nothing is given here. Okay, no problem. That is a half diagram is given. The voltage gain of the amplifier at mid band and input resistance will be of order of. What is the input resistance and what is the voltage gain? Mid band voltage gain of the circuit. Okay. So, dear students, if the voltage gain is asked, it is unbypassed resistor. Always remember one standard formula. Here it is an internal resistance RE. Here it is an internal resistance RE. But no need to make the complete diagram. Just in my previous class already I have given the shortcut. Directly you can write the mid-band voltage gain. So what is the small RE? RE is given by Vt by IE. Vt by IE, or IE is nearly equal to IC. Beta, because beta is 100, it is a very large value. The operating at 1 milliampere means that is the value of IC or IE, nearly equal to IE. You can find the small value RE. Vt, if it is not given, then you can take 25 millivolt. 25 millivolt upon 1 milliampere means milli cancel 25 ohm. This is the value of RE. And then mid-band voltage gain is given by V0 by Vs. Everyone give me the answer. What is the, which answer is correct? 240, 120, 10 and 6. Which is the correct answer? Or when it is a MCQ, you have to choose what? You have to choose the correct one, right? Best answer. Which one is the best answer? Tell me. Then, what is the voltage gain here? Minus of RC upon small re plus capital RE. That is the approximate answer. Here, what is the capital RE? 6 kilo ohm. 6 kilo means 6000 ohm divided by small re. What is the small re? Only 25 ohm. And what is this 1 kilo ohm? 1000. RE means 1000 ohm. Now 25 is negligible as compared to 1000. We can say nearly equal to minus 6000 divided by what? 1000, and you will get the answer minus 6. So what is the magnitude of the voltage gain? 6. Magnitude of the voltage gain is what? 6. This is the answer, 6. Only one answer is 6. If suppose you have the idea about that, then directly you can put this answer 6. Only one answer has the answer 6. But if the input resistance is asked, what is the input resistance for this particular question? Remember, this is the RE model. This is a small RE, this is emitter, this is collector, and this is the base. Now, capital RE is connected here from collector to ground. When we are making this diagram, this is connected to ground, VCC will become 0. That is the method. This is the RC. Here we are taking the output. Here we are taking the output. Here we are giving the input. So what is the input resistance seen by this Vs? Input resistance seen by this Vs, that is question. Input resistance will be off. The input resistance, when we want to calculate Rin, that will become Vs upon Ib. Vs upon base current. What is the current given by that? But actually here we are having the emitter current IE. Or emitter current is nearly equal to what? Collector current, because beta is large 100. We have to calculate the approximate answer. Always remember, you will write Vs is equal to what? IE into small re plus capital RE. Or small re you can write 1 plus beta times of IB into small re plus capital RE. So what is the 1 by Vs by beta? That is called Rin. Vs by Ib is equal to 1 plus beta times of small re plus capital RE, and that will give you the input resistance. That will give you the input resistance. So what is the value of the beta in this question? Beta is given as 100. So 1 plus 100 will become 101. What is the value of the small re? 0.025 kilo ohm, that is the 25 ohm. What is the value of capital RE? 1 kilo ohm. Now multiply it and you will get the answer. I think 103.5 you will get. 103.5 kilo ohm. That is the answer for this question. Okay. So in next time they will ask what is the voltage gain and what is the input resistance. So with the help of a small signal model or with the help of RE model, you can find the input resistance. Okay, and that is the method how we are going to find the input resistance seen by the base terminal. This is the base terminal. Okay. Yes, Bhavna, your answer is correct, and this is given. Yes, Dinesh, your answer is also correct. 1 plus beta capital R into small re. That is the answer for input resistance. So this is the answer D. Next question. The circuit shown in the figure, the transistor of the voltage divider circuit has beta is equal to 60. The emitter base junction has forward bias voltage drop of 0.7 volt. The breakdown voltage of the Zener diode is 12 volt. The current flowing through the Zener diode is. So this is in a GATE exam, they will not give you the name of the circuit and so on. Actually, it is a series voltage regulator. Actually, it is a series voltage regulator. Voltage regulator. A standard circuit of series voltage regulator. So MCQ 1 marks question, you have to find the current here through the Zener diode only. Right? Beta is given, drop is given, Zener diode drop is given. Okay. What is the answer? Everyone give me the answer in comments box. Yes, yes. Tell me. Then this is the series voltage regulator. So in a series voltage regulator, please take the screenshot and give me the answer. Simply, new students, please watch this. Always remember, transistors should be in active region. Transistor should be in active region and general diode should be in breakdown region. If that is the case, then you will get the VE or V0. This is the VE and V0. Write down the KVL from this point to this point. In this loop, write down the KVL. You will get V0 is equal to, or VE is equal to, VZ minus VB. That is nothing but 12 minus 0.7. 12 volt is given as a breakdown voltage. 11.3 is the output voltage. Now, why we are calculating the output voltage? Because current through the Zener diode is asked. Once you will get the output voltage, remember how we are going to find the IZ. First of all, we have to find this current, I. This I is divided into two parts, IZ and IB. IZ plus IB. Now we have to find the IZ. So what is the IZ? I minus IB. I minus IB. Now this is the, once we will get the V0, we will get the output current or load current. And load current is nothing but IE, emitter current. Load current is nothing but IE. That is what? Emitter current. So IE is equal to 1 plus beta times of IB, and that is nothing but V0 by RL. So what is the IB is equal to, what is the one beta? Beta is given as 60 to 61. What is the V0? Already we have calculated 11.3 upon 1 plus beta, that is the 61 into RL. What is the RL given? 1 kilo ohm. 1 kilo ohm. You will get the answer in milliampere. Get the value. What is the IB? Get the value of IB. Okay. Once you will get the IB, what is the value of I? Remember, the voltage at this point is 20 volt. This is the 20 volt. And voltage at this point is VZ. What is the VZ? 12 volt. This is the 12 volt. So 20 minus 12 divided by 200 ohm. 20 minus 10. I is equal to 20 minus 12 divided by 200 ohm means 0.2 kilo ohm. Convert it into kilo ohm. So it will become 8 divided by 0.2. 8 divided by 0.2, that is 80 by 2, 40 milliampere. 40 milliampere is the I. Finally, you will get IZ, I minus IB. Which answer is correct? So 11.3 divided by 61, this is the IB, minus 40, that is 40 से minus कर लीजिए, and you will get 39.8 milliampere, nearly equal to 39.8 milliampere. Yes, 39.8, that is the answer. If it is in this question power dissipation is asked, then you can find the VZ into IZ. That will be the question. Right, tell me, transistor is in which mode? Common emitter, common collector or common base? Common emitter, common collector or common base. This type of MSQ they may ask. What is the power dissipation across the Zener diode? What is the current through the Zener diode? What is the power dissipation across the transistor? And what about the transistor? It is in common emitter, common collector or common base configuration. Okay, next question. Give me the answer in comments box. That is the MCQ 1 marks. Then this is the MSQ, again MSQ of only 1 mark. Quick response, quick standard circuit, standard question, right? We have number of standard application of from operational amplifier. Get the command over that. MSQ within 1 minute we can solve, or some students will solve within 30 seconds. Which answers are correct? Tell me. For the circuit of figure with an ideal operational amplifier, which statements are correct? It is a all pass filter. It is a minimum phase system. Range of the phase shift at the output with reference to the input is from minus pi to 0, and it is a low pass filter. Right? So which answers are correct? MSQ. There is no negative marking. Please give me the answer in comments box. For MCQ, there will be negative marking, but for numerical answer type question and for that MSQ, there is no negative marking. So, one is given A and C. C is correct. Okay, Bhavna. For the circuit, देखिए, this is the standard circuit. Always find this R1 and R2. R1 and R1 are equal. C is connected, R is connected. This is a all pass filter. It is not a high pass or low pass. It is a all pass filter. The first statement is correct. Now, from control, minimum phase and non-minimum phase. What about the all pass filter? All pass filter is example of what? Non-minimum phase. All pass filter is example of non-minimum phase. That is the transfer function. 1 minus j omega t upon 1 plus j omega t. So we are getting maximum phase because we have to add the phase of the numerator as well as phase of the denominator. And that's why we are getting the, what is the total phase? 2 tan inverse minus omega t. So this is the example of non-minimum phase. That's why it is wrong. That's why this is the wrong statement. We are using all pass filter in control system to compensation, right? Leader lag as a leader to compensate the phase margin and gain margin. So next one, range of the phase shift at the output V0 with reference to the input is from minus pi to 0. Yes. In my number of session, already I have given, there are two standard diagram. Remember, one, this is the diagram and that is the second one. Both are all pass filter. Both are all pass filter, right? But watch this. This is a case of low pass filter. Only when I am considering the RC low pass filter and when I am considering this RC, this is the high pass filter. High pass filter is leading circuit and low pass filter is lagging circuit. So this is the simple way to revise. Sir, how we can revise this? So low pass is a lagging. The phase shift for this is minus pi to 0. And the phase shift given by this all pass filter is 0 to what? Pi, positive. For one it is 0 minus pi to 0 and for other one is 0 to pi. So this is a minus pi to 0. This is the right answer. Range of the phase shift. It is a low pass filter, wrong. So A and C. If you are giving the partial answer, then though there is no negative marking, but you will not going to get the marks. You are not going to get the marks. Okay. That is the A and C MSQ. So in 1 marks, if suppose we are getting the MSQ, then quickly we have to give the response. Now, this is the MSQ of 2 marks. If suppose it is of 2 marks, then definitely there may be some numerical or some part you have to calculate, some conceptual part. Consider the circuit shown. Which statements are correct? Tell me, everyone. What is the name of circuit? तो बहुत सारे लोग रेस्पॉन्स कर रहे हैं, बहुत सारे लोग रेस्पॉन्स नहीं कर रहे हैं. भावना, दिनेश, बहुत ही अच्छा परफॉर्मेंस, आप लोग सही जवाब दे रहे हैं. तुषार, सुरजीत, you can join my telegram channel if you want the PDF of all this session, that is electronics by Sanjay Rathi. Okay, to join that telegram channel now. बाकी स्टूडेंट्स अभी आप लोग जवाब दीजिए. इट विल गिव यू द कॉन्फिडेंस. ट्राई टू सॉल्व दिस क्वेश्चन. हमेशा अपने साथ एक कॉपी या रफ पेजेस रखिए, ब्लैंक पेजेस रखिए इस तरीके से, ताकि जिसको आप आराम से सॉल्व कर सके. कॉपी रखिए तो ज़्यादा बेटर है. जो भी आप सॉल्व करेंगे वो कम से कम एक पर्टिकुलर पॉइंट पर नोट हो जाएगा और आप उसको फेयर तरीके से बनाइए एंड इट विल हेल्प यू. क्योंकि जो क्वेश्चन में आपको प्रॉब्लम हो रही है ना, वही आपकी स्ट्रेंथ बनेगी. ओके, तो बताइए जरा. Right now, what is the answer for this one? Consider the circuit shown. Which statements are correct? It is MSQ. It is written here. 2 marks question. Then it is a negative clamper circuit. DC level of the output waveform is minus 8 volt. For proper functioning of the given circuit, load resistance should be as low as possible. The swing of the output voltage is equal to the swing of the input voltage for this circuit. Okay. So which answer is correct? So Dinesh giving A and D. Okay. You are giving A and D, my dear. Now watch this. Take a screenshot of this and give me the answer. Give me the answer. It is a negative clamper circuit, DC level, or proper functioning, or what swing of the output. Now, remember, we are having the two types of standard circuit. One is this one and second one is this one. And here we are connecting the RL. This is the actually RL. This is the C. And we are writing like this, VC. Okay. Now, direct revision, for revision, quick revision, remember that if it is downward, and this is the current, direction of the current upward and downward. If it is downward means, just to revise, that is not the conceptual thing, but just for revision, downward means it is a negative clamper. It is a negative clamper. And this is a positive clamper. Okay. Second thing, VR means output is clamped at 2 volt, means highest level is 2 volt. Here is the lowest level is VR, that is 2 volt. If it is given that the lowest level is 2 volt, highest level is 2 volt in this case. And the swing will remain same. That is, for example, that the swing is what, 20. So what is the answer for this question? Highest level is 2 volt. Lowest level, you have to maintain the swing. So highest level is 2 volt. Lowest level will become minus 18 volts, so that the swing will remain same, shape will remain same, everything will remain same. Or in case of positive clamper, lowest level will become 2 volt. This is 2, this is 22. Now tell me, what is the average value or DC value for this? Or what is the DC value for this? If you want to find the DC value, always remember what is the DC or average value? Maximum plus minimum divided by 2. So minus 16 divided by 2, what is the average value for this? Minus 8. And what is the value? 22 plus 2, 24. 12 is the average value. So ये देखो, ये gap कितना? What is this gap? 10. What is this gap? 10. Similarly, what is this gap? From minus 8 to 2, that is the 10. From minus 8 to minus 18, that is the 10. So what is the middle value? Minus 8. Minus 8 volt. Which answers are correct, Dinesh? Now you are giving the wrong answer. It is a negative clamper circuit. DC level of the output waveform is minus 8 volt. That is also correct. Swing of the output voltage is equal to the swing of the input voltage. Yes, always remember, in case of clamper circuit, shape of the output voltage and swing of the output voltage is similar to the shape and swing of the input voltage, ideal condition. But finally, RL, for proper functioning of the given circuit, always remember that load resistance should be as high as possible. As high as possible, so that once the capacitor will charge, it will not discharge. Okay, that is the condition. So this condition is wrong. Low, it is written low. So that is the wrong. So ये है MSQ ABD. ये हो गया AB de Villiers. Okay, 360 degree. Okay then. Now next one. This is a positive and negative clamper. Remember these things. These are important things. Now, tell me again one question. The transistor used in the circuit shown below has a beta of 30 and ICBO is negligible. So always remember, why EDC and analog is going to play a crucial role in your selection. For electronics student, EDC and analog is a core subject. Right, we have to use the concept of network, concept of EDC and so on. And again, the analog is also important for electrical student, instrumentation branch. Okay, but it is a core subject for electronics student. तो थोड़ा अच्छा तैयार कीजिए, थोड़ा ये आपको सपोर्ट करेगा और बहुत ज़्यादा लेंदी करने की जरूरत नहीं, कॉन्सेप्ट अच्छे से बनाइए और क्वेश्चन बनाइए. बताइए. The transistor used in the circuit shown below has a beta of 30 and ICBO is negligible. Reverse saturation current is negligible. If the forward voltage drop of the diode is 0.7 volt, then the Zener diode current IZ is. They will ask what is the Zener diode current actually. Zener diode current, what is the IZ here? and diode is connected, and what is the drop across the diode? 0.7 volt. Now my dear friend, first of all, always remember, normally we are considering that the Zener diode is what? Breakdown, and transistor is in what? Active region. Okay, but remember, always remember, when we want what is the current through the Zener diode, that current should be flow from N to P side, and this current should be greater than 0 or positive. It should be positive current. If suppose I am going to get the negative value of the current, means what? That diode will become what? Forward bias. The diode will become forward bias. Okay. Now in this case, it is asked what is the Zener diode current. Now my dear friend, first of all, let diode is reverse bias. Always remember. Always we have to consider, if it is asked, then let diode is reverse biased. Once it is reverse biased, it will act as open circuit. The 12 volt battery is connected here. Then this is minus 12 volt. Yes, everyone, give me the answer. What is the answer for this question? This is a very, very important one. Right? Very important question, my dear. Right? This is a standard circuit. Here we are connecting the Zener diode. Here we are connecting the diode. That is the RC is connected 2.2 kilo ohm. Minus 12 volt battery is connected here. 15 kilo ohm resistor is connected here. What is the role of the Zener diode? Everything they may ask. This is a standard circuit. So remember, first of all, consider let the Zener diode is reverse bias. Then 15 kilo ohm, 1 kilo ohm, 15 kilo ohm, 1 kilo ohm, and this diode is forward bias. This is the drop is 0.7 volt, 15, 1, and here it is the 0.7 volt, and this is connected to ground. No problem, 2.2. And then you can find the base current IB. Let this is I. This I is similar to IB. And then, my dear friend, find this value and find the voltage at this point. Right? Find the voltage at this point so that we can find the voltage drop across the diode. So write down the KVL from this point to this point. When I am writing the KVL, it will become 0. This is 0. 15 plus 1, 16 times of IB. 15 plus, because I is equal to IB. 16 times of IB plus 0.7 plus 0.7 minus 12. So what is the IB will become? IB will become 12 minus 1.4 divided by 16. Right? That is the 10.6 divided by 16 milliampere. This is the value of IB. 12 minus 1.4. This is the 16 minus this one. Check my calculation. Now, once you will get the IB, tell me what is the voltage at this point. When I want to find the voltage at this point, like this is the Vx. So what is the value of Vx? What is the voltage at this point? 0. So what is the voltage at this point? This is the plus minus. So definitely we can find this voltage from this point to this point. We can write 0 is equal to 15 times of IB. I is nothing but IB plus what? Vx. So what is the Vx is equal to minus 15 times of IB. Minus 15 times of IB. So it will become minus 15 into 10 raised to power 10.6 upon what? 16. Now, what is the IB or what is the Vx? 15 into 10.6, use virtual calculator, divided by 16. You will get minus 9.9375. Minus 9.9375 volt. Why I am calculating this voltage? So that I will check whether the Zener diode is only reverse bias or it is actually breakdown. Then your comments are not visible to me. 1 minute. Yes, guys. Tell me. 1 minute here. Okay. So reverse bias or this one. To find the Zener diode, this is the Zener diode. Already we have calculated across the Zener diode voltage. This is minus 12 volt. This is minus 12 is given. This is the minus 12. Already we have calculated the Vx and we are considering that the diode is reverse bias. So what is the voltage here? Minus 9.9375. Everyone calculate the drop across the diode. What is the voltage across the diode in reverse direction? So you will have to calculate the VD. You will write minus 9.9375 minus of minus 12. Minus of minus 12. You will get 2.06 voltage. 2.06 volt only. If this is the 2.06 volt, tell me the Zener diode is breakdown. No. What is the Zener diode breakdown voltage? It is given as 5 volt. This is nothing but Zener diode breakdown voltage that is given as 5 volt. Vz is equal to 5 volt. So if it is a 5 volt, we are getting only 2.06 volt in reverse direction. It is less than the breakdown voltage. And that's why the diode is not in breakdown region. It is simply reverse bias. Then what will be the current, guys? What will be the current, guys? Yes, Iz is 0, Dinesh. Iz is 0 in this diagram. Iz is 0 in this diagram. Finished. If the power dissipation is R, power dissipation is also 0. Okay, so that is important question. In this question, they may ask what is the collector current IC. So please try to solve the collector current. It is a mock test. I am asking IZ, but you can find the IC. Whether the transistor is in active region or in saturation region, you have to decide. Already I have given that Zener diode is in what? Reverse bias. Okay, but we are considering, we are simply solving what? This base current. Now you can find whether it is in saturation or in active region. Okay, then next question. So always remember that is the method. First of all, consider the Zener diode is reverse bias. Make it open circuit. Find the drop across the diode. If it is more than breakdown voltage, then it will be breakdown. Otherwise, we have to consider that diode is reverse bias. Okay. Next question. The NMOS transistor operate at ID is equal to 0.4 milliampere and V0 is equal to 0.5 volt. The transistor has VT, Kn, mu and Cox 100 microampere per volt square. This is a square. L is equal to 1 micrometer, W is equal to 32 micrometer. Neglect the channel length modulation, the value of resistance Rs. You have to find the series resistance Rs or source resistance. Source resistance Rs. Now take a screenshot and try to solve. Now if it is Rs is asked, how we can solve this? This is asked, and what is the value? Minus 2.5 volt is connected here. Minus 2.5 volt is connected here. Gate is connected to ground, and RD is also not given, not required. 2.5 volt, and ID is given as 0.4 milliampere. 0.4 milliampere. VD or V0. This is the VD or V0. 0.5 volt is given. 0.5 volt is given. 0.5 volt. Now if you want to find the RS, now we have the value of ID. What is VGS? If you get the value of VGS, then you can apply a KVL in this path. When I am applying the KVL in this path, it will become 0 is equal to VGS plus ID into RS minus 2.5 volt. So what is the RS is equal to 2.5 minus VGS upon ID. Now you have to find the VGS because we have the value of ID. Now what about the MOSFET? It is in which region? First of all, VD is given as 2.5 volt. And what about the VG? That is 0. Means VD is greater than VG. It means VD is greater than VGS. It means VDS is greater than VGS minus VT, and that's why it is in saturation. That's why we can say it is in saturation. Now we can use the formula for saturation. ID is equal to half of K and S W by L VGS minus VT the whole square. What is the ID given? 0.4. Why we are getting the formula for the current? Because we want to find the VGS. 1 by 2 into, what is the K and S W by L given? K and S is given as 100 microampere, convert it into milliampere, and 32 divided by 1. 0.1 milliampere, 32 divided by 1. You have to find the VGS. What is the VT given? 0.7 volt VT is given. Whole square. Now, this will become 4, 8. 8 divided by 32. Root over that. That is the VGS minus 0.7. This is 1 by 4. This is 1 by 2. VGS minus 0.7. So what is the VGS is equal to 0.7 plus 0.5. No doubt when we are calculating the root, it will be what? Plus minus 1 by 2. But remember, we are using the plus value because the threshold voltage should be always greater than what? Sorry, VGS should be always greater than threshold voltage. Otherwise, it will be in cutoff. But we are having the current. So what is the value of VGS? 1.2 volt. Once you will get the VGS, now directly you can find the RS. 2.5 minus 1.2 divided by ID 0.4. Calculate the value. I think you will get the 3.25 kilo ohm. Because current it is in milliampere and voltage in volt, then resistance will be in kilo ohm. Okay. So in exam, and that is the approach you have to solve. Okay, 3.25. Yes, Bhavna, your answer is correct. VGS is, you are getting the Bhavna of 0.526. No, VGS is I think 1.2 volt. 1.2 volt. This is the 3.25 kilo ohm you will get. Right, calculate it. If you are getting the VGS less than 0.7, the current will become 0. It should be greater than threshold voltage. 3.25 kilo ohm. It should be greater than threshold voltage. Okay. Then that is the answer. This is the kilo ohm. Next one. भाई इसके बाद आएंगे आपके फेवरेट अंकित सर. ओके, बस 2 क्वेश्चन और है. नाउ देन अंकित सर विल ज्वाइन. तो प्लीज कंटिन्यू एंड शेयर द लिंक ऑफ दिस सेशन, सब्सक्राइब आवर चैनल and like the session, right? And wait for what? Ankit sir. Just I will solve. This is the second last question, and again we will solve one more question, and then Ankit sir will start. Okay. Then please tell me what is the answer for this question. The circuit shown in the figure has an ideal operational amplifier. If R1 is equal to 40 kilo ohm, C is equal to 100 microfarad. It is given. It is given 100 microfarad. R is given as 10 kilo ohm, value of R, this R is given as 10 kilo ohm. Then the oscillation frequency in kilo radian per second, in radian per second, and the condition to sustain the oscillations. The condition to sustain the oscillation. Everyone give me the name of this circuit. What is the name of this circuit? Very good afternoon, Ankit sir. अच्छा आ गए हैं अंकित सर हमारे बीच में. राइट तो अंकित सर जस्ट ज्वाइन करेंगे. इस जस्ट मैंने ये 2 क्वेश्चन बनाया और फिर आपके अंकित सर आ जाएंगे. राइट तो रेडी रहिए, अपने क्वेश्चन बनाने के लिए आप तैयार हो जाइए. नाउ व्हाट इज द आंसर फॉर दिस वन? व्हाट इज द आंसर फॉर दिस क्वेश्चन? तो व्हाट इज द नेम ऑफ दिस सर्किट? इट इज अ स्टैंडर्ड ऑसिलेटर. ओके राइट, गिव मी द आंसर इन कमेंट्स बॉक्स नाउ. Take a screenshot and try to solve 20 kilo ohm, 10 kilo ohm, 10 kilo ohm, 80 kilo ohm. Now this is a wind bridge oscillator, and for wind bridge oscillation, right, this is called, normally we are writing, I am just writing R, C, R dash, C dash. We are right. These two are connected in parallel, in series, and these two are in parallel. So that is the standard. This is called RF. This is called what? R1. That is normal. So what is the condition? That is called balance bridge condition. RF by R1. RF by R1 is equal to RF by R1 is equal to 2R. This R by R dash. I'm giving you the standard answer. Then R by R dash plus C dash by C. Because always remember the capacitor, the behavior of capacitor is just opposite. So what is the balance bridge condition? C dash by C. That is the condition. And what is the frequency of oscillation in radian per second? 1 by root over R dash C dash. That is the standard one. That is the standard. But here the value is changed. When the value is changed, 1 by root over. What is the R here? Actually R is 2R. In standard diagram it is the R. Actually it is a 2R. Into what is the R dash? R. What is the C dash? 2C. Multiplied. And what is the C? C. Now, so omega will become 1 by 2 root bahar aa gaya R and C. 1 by 2 into R. What is R is given here? 1 minute. R is given as 10 kilo ohm and C is given as 10 microfarad. 10 into 10 raised to power minus 3 plus 3, 10 kilo ohm, 10 microfarad, 10 raised to power minus 6. Okay. Then it will become 10 to the power 3 means ye aa gaya 1000 divided by 10, 10, 100 into 2, 200. Check my calculation. 5 kilohertz. 5 kilohertz is the frequency. Remember, it is a audio frequency amplifier. It is a audio frequency amplifier. So this is the Wien bridge oscillator. It is a variable frequency oscillator, audio frequency oscillator, not amplifier, sorry, oscillator. Okay. So which answer is correct? 5, 5. Now what is the condition for oscillation? Second one. What is the condition for oscillation? So what is the condition? RF by R1 is equal to R by R dash, C by C dash. Now RF by R1 is equal to R by R dash plus C by C dash by C. Remember, this is the R, this is the C, this is the R dash, this is the C dash, this is the RF, and this is the R1. So right here, R1 by R2. I am writing the standard answer, but compare R1 by R2 is equal to 2R by R, 2R by R plus C dash. What is the C dash? 2C by C. RR cancel, CC cancel. It will become 2 plus 2. That is nothing but 4. So what is the relation between R1 and R2? R1 is equal to 4 times of R2. So R1 is given here. R1 is given in the question. R1 40 kilo ohm is given. So what is the R2? R2 will become R1 by 4. 40 divided by 4, 10 kilo ohm. 40 divided by 4, that is the 10 kilo ohm. Yes. So R2, Surjit, your answer is correct. That is the 10 kilo ohm. And that is in kilo radian per 5 kilo. Oh, sorry, मैंने हर्ट्ज लिख दिया क्या? किलो हर्ट्ज नहीं है, रेडियन पर सेकंड है. किलो रेडियन पर सेकंड. गुड दिनेश, यू आर करेक्ट. किलो रेडियन पर सेकंड. In hertz means we have to divide it by what? 2 pi. Omega naught by 2 pi. Then it will be in kilohertz or hertz. That is the kilo radian per second. Be careful about that. Okay. Yes. देखो ऐसे ऐसे silly mistakes तो है ये. अब last question. So this is about the Wien bridge oscillator, right? So that is the standard. Remember the formula. This is a very, very important diagram. Standard diagram. That's why same type of questions we are getting from this circuit. Last one. Again, it is a MSQ 2 marks. MSQ and is of 2 marks. Tell me what is the answer. ये हो ना response और पूरा send कर दो भाई, share कर दो. थोड़ा फायर वायर जला दो, आग लगा दो भाई, अब ठंड का मौसम है, आप लोग बिल्कुल आराम से रिस्पॉन्स कर रहे हैं, जोश में आ जाओ, मॉक टेस्ट है, बस सीरियस नहीं होना है, सीरियस लोग सीरियस हॉस्पिटल में पाए जाते हैं, सिंसियर होना है, सिंसियर एफर्ट दीजिए, गिव योर बेस्ट, राइट, अपना देते रहिए बेस्ट, आएगा रिजल्ट, अभी भी आपके पास काफी टाइम है फॉर क्विक रिवीजन, लेकिन कॉन्सेप्चुअली रिवाइज कीजिए, अच्छे अच्छे क्वेश्चन बनाइए। गेट में ना क्वेश्चंस बहुत आते हैं, न्यूमेरिकल बेस्ड पेपर होता है ज्यादा, बट दिस टाइम दैट इज न्यू थिंग इज व्हाट, एमएसक्यू, मल्टीपल सेलेक्ट क्वेश्चन, राइट। तो एक बार जरा पूरे अच्छे से कमेंट्स दे दीजिए, हाउ इज द जोश, बहुत सही चल रहा है आप लोगों का, कैसा लग रहा है ये टेस्ट पेपर। Now, the inverting operational amplifier shown in the figure has an open loop gain of 100. Feedback mechanism is voltage. Tell me, we are having 4 types of feedback: voltage series, voltage shunt, current series, current shunt. So, in a non-inverting operational amplifier, the feedback mechanism is voltage series feedback. But it is an inverting operational amplifier. In inverting operational amplifier, the feedback mechanism is voltage shunt feedback. Theoretical question. Voltage shunt feedback, and that's why the first answer is what, wrong. First point is wrong. Okay, then second thing, normally we are, yes Bhavna, you are correct. Second is, it is given -9, no problem. Now it is not, open loop gain is not infinite, means it is a practical. Normally students are thinking that gain is minus RF by R1. They will give the answer -10 by 1, that is the answer is -10, and that's why this is wrong. But remember, open loop gain is not infinite, it is 100. If it is 100, then remember, this is RF, this is R1, so beta is equal to R1 upon R1 plus RF. That is the value we are saying, that it will become 1 upon 11. That is the value of beta. And for inverting operational amplifier, practically the gain will become AV beta upon 1 plus AV beta into RF by R1 with negative sign. That is the formula with voltage shunt feedback. 1 minute, give me, what is the problem here? Okay. Then this is what, -100 into 1 by 11 upon 1 plus this AV open loop gain is given as 100 into 1 by 11 into RF 10 upon 1. Now calculate this. So that is called exact formula for gain if the gain is not infinite or when we are not using the ideal operational amplifier. So you will get the gain nearly equal to -9. You will get the nearly equal to -9, and that's why this is also correct. AV is equal to what? V0. This is wrong, this is correct. Now what is the input resistance seen by the Vs? When we are saying the input resistance seen by the Vs is Tushar, yes, you are giving the BCD, okay. When we are saying that input resistance seen by the Vs is 1.1 kilo ohm, means, remember, what is the ideal condition? Under ideal condition, the input resistance is R1, because up to this point the input resistance, the current is 0. We are using the virtual short concept in case of ideal, and that's why the input resistance is R1. So 1 kilo ohm. So some student will give the answer that is the C is the wrong one. C is the wrong. But practically, when we are applying the Miller's theorem, then we can break this resistor as 10 upon 1 minus AV, and this is become 1 kilo ohm. And remember, this is the V0. So by using the Miller's theorem, that resistor is break 10 AV upon AV minus 1. Okay. Now we can apply the Miller's theorem here. The voltage at this point is called Vn. The voltage at this point is called Vp. This voltage is called Vi. This voltage is V0. This is Vi. When we are taking Vi is equal to Vn minus Vp, always remember V0 is equal to AVVI, and you have to use the less than 0 value. For example, open loop gain is given as 100, you have to choose minus 100. Why minus 100? Because we are defining the Vi as Vn minus Vp. If the Vi is defined as Vp minus Vn, then you have to use the plus 100. You have to use the minus 100, open loop gain is given. Now up to this point, the internal resistance of the operational amplifier is infinite because nothing is given in the question. The input resistance is infinite. This is in parallel and that is. So what is the R in now? What is the input resistance seen by the V in? It will become 1 kilo ohm plus 10 minus 1 minus AV parallel with infinite because it is the infinite. 1 plus 10, 1 minus of minus 100. And that will become 1 plus 10 divided by 101. This is nearly equal to what? 1.1 kilo ohm. 1.1 kilo ohm. So you can watch the recorded session. That is the 1.1 kilo ohm. ये आगे value. So always remember, in a practical operational amplifier, the value will be greater than what? R1. That is 1.1 kilo ohm. Okay. Then अरे जाइएगा नहीं, बस अब बस मेरे साथ ही जैसे ही खत्म मैं करूंगा और अंकित सर आ जाएंगे यहां. देन लास्ट वन, error in approximated calculation will be. Now that is the exact one. This is the exact one. And what is the approximated? AVS. 1 AV beta is very greater than 1. Then AV beta cancel out. We can neglect 1. AV beta cancel out. And the gain will become RF by R1. This is called approximated gain. Or always remember, the magnitude of approximated gain is greater than exact gain. And what is the error? There is a standard formula for the error. Error is equal to approximated, because the magnitude of approximated is greater, minus exact upon exact into 100%. By solving this, you will get 1 by AV beta into 100%. What is the AV? 100. What is the beta? 1 by 11, 100, and that will become 11% is the error in calculation. Or you can directly find the percentage variation. What is the approximated value? You are calculating the 10 RF by R1. What is the exact value? 0.9 divided by 0.9 into 100%. Again, you will get the error nearly equal to what? 11%. Magnitude. Error in what? Magnitude. RF by R1, already we have calculated the exact value 0.9. 10 minus 0.9 upon 0.9 into 100%. It will give you the exact value. Okay guys, तो ये है यहाँ तक. Now Ankit sir will join. Right, so please like the session, subscribe.
Am I audible to all of you? Everything all fine regarding the audio and the video? So students, in this mock test, I will be taking up the questions for signals and system and engineering mathematics. So I can see students here who are frequently answering the questions from different subjects. So students, all of you, welcome to the session. Let me introduce myself. This is Ankit Joshi, and I have been teaching in this domain since many years. And yes, my subjects of interest are analog circuits, signals and system, and engineering mathematics. Just now I have seen you are solving questions with legendary Sanjay Rathi Sir, and now we will be solving questions from signals and system, and then we'll be moving towards engineering mathematics questions. So students, 8 marks questions we have or from signals and system, and yes, 13 marks questions from engineering mathematics. So they are in actual trend with the actual papers for ECE. So stay tuned for the best of the questions and try to solve these questions with me. Whatever your issues related with the questions, you can also immediately ask your doubts. I will be providing you the solutions as well. Students, one small announcement for you. 90% scholarship. You can just go for this scholarship test at 8 p.m. in December. Yes. So here comes your first question. All set? So of course these are the questions from signals and system. I guess 5 questions are there. So this is an MCQ for 2 marks. This is an MCQ for 2 marks, and students, you have to solve this integral minus infinity to infinity. There is an impulse signal multiplied by sine square. So you can use the property of impulse. Okay. So all set. Yes, students. So delta AT minus B. What you can write here? क्या लिख सकते हैं आप इसकी जगह पर? Here. Delta AT minus B. Yes, impulse function whose argument is AT minus B. If you take A common, this will become A out and T minus B by A. And by scaling property of impulse signal, very good Bhavna, scaling property of impulse signal, we can write this as 1 upon A delta of T minus B upon A. Very good. So as the solution of this integration, I can take 1 by A out, 1 by A out. See, this delta AT minus B is replaced by this term. So 1 by A is out. Integration from minus infinity to plus infinity. And the remaining will be delta T minus B by A. Delta T minus B by A. And further this is multiplied by sine squared T minus 4 dt. So students, it is just a matter of checking whether this impulse is lying in the range of integration. So range of integration is the overall range from minus infinity to plus infinity. So all real numbers are lying in this interval. So the answer for this integration will be the adjacent function, this function at the position of the impulse. So this function at the position of the impulse, this function at the position of the impulse. So all my dear students, 1 by A is already out. So answer will be sine square. And in this function, T will be replaced by B upon A. T will be replaced by B upon A minus 4 as it is. So this is our answer. This is our answer. So you need to compare it with this given answer. Compare कीजिए. So what you are getting? You will get P equal to A. Then Q equal to B. Then what? Yes, R is equal to again A, and yes, S is equal to 4. S is equal to 4. So A, B, A, 4. A, B, A, 4. Option B is the correct answer. So students, just keep track of the answers you are giving. Which of the questions have gone correct? So this question was there for 2 marks and this was an MCQ. So just try to just make a table in your rough note. That is question number 41. You scored 2 marks, correct? Okay, yes, this question was from signals and system. And next question now, moving towards the next question. See this one. So this is an MSQ, multiple select question. More than one correct answers will be there. Okay, this is a 2 mark question, students. So two discrete time signals x of n and h of n are both non-zero only for n equal to 0 and 1, 2. So students, हमारे पास दो signals है. We have got two signals, x of n and h of n. It is given that x of 0 is 1, x of 1 is 2 and x of 2 is 1. It means x of n's 3 samples are given. What are these 3 samples? 1, 2 and 1. 1, 2 and 1. 1, 2 and 1. This is the 0th sample. Then what? Then we are writing the samples of h of n. h of 0 is given as 1. h of 0 is given as 1. But other 2 samples are missing. So I am just assuming them to be small a and small b. Understood? Now what is the length of x of n? How many samples are there in x of n? कितने samples है भाई x of n में? Sir, x of n has got 3 samples. So let us say length of x of n is L, which is L equal to 3. And length of h of n is say m, which is again 3. So what is y of n? Y of n is x of n convolution with h of n. This is mentioned in the problem. See, y of n be the linear convolution of x of n and h of n. So what is the length of y of n? Y of n का length क्या होगा? Length of y of n will be L plus m minus 1. So 3 plus 3 minus 1, that will be 5. I'll give you time to see this. Yes, so length of y of n will be 5. So students, y of n will be having 5 samples, of course starting from the 0th one. So y of 0 is not given, but y of 1 is given as 3. Then y of 2 is given as 4. Y of 3 and y of 4 are not given. Let us say y of 3, this is y of 4. Correct? So students, we will apply the convolution between x of n and h of n, assuming h of n to be 1ab. So in order to calculate convolution, I will be using this tabular form method. So here I am assuming signal x of n, and here I am going to assume h of n. So h of n samples are 1, a and b. And what about x of n? X of n is 1, 2, 1, 1, 2, 1, 1, 2, 1. Yes, come on. Students, are you following how to calculate this convolution in this tabular form method? This is discrete convolution. 1 into 1, then 1 into 2, then this 1 into 1, then a, then we have twice a and again a, then b, twice b and again b. Now we have to group them together by drawing diagonals. Yes, all my dear students, y of 0 is 1, y of 1 is a plus 2, yes Dinesh, all fine. Y of 2 is 2a plus b plus 1, y of 3 of course not required, and y of 4 is b. Now what is given? they have given you y of 1 as 3, y of 1 दिया है 3, y of 1 is given as 3, y of 1 is given as 3, y of 1 is given as 3. So 3 minus 2, small a will be 1. Yes sir. Y of 2, y of 2, y of 2, y of 2 given as 4, y of 2 is given as 4, y of 2 is given as 4. So 2a, that is 2, plus b plus 1 equal to 4. So b will be 4 minus 3, that is 1. So we have obtained the value of y of 1. Yes, the value of small a and small b. So what is y of 3? Y of 3 is a plus 2b. A plus 2b. Yes, just a moment, Bhavna. Let me allow to calculate. Y of 3 is a plus 2b. A is 1 plus 2, that will be 3. Y of 4 is nothing but b. And b is nothing but 1. So y of 3 is 3. Y of 4 is 1. I am coming back on your screen. Yes. Now, y of 3 is 3. This is correct. Option A is the correct one. Y of 3 is 3. देख लो भाई, y of 3 क्या आया है? Then y of 4 is 1. This one is also correct. Y of 4 is 1. See here. Y of 4 is 1. H of 1. H of 1. Yes, beta. H of 1 is A. And A is nothing but 1. This is also correct. And H of 2. H of 2 is actually B. And B is also 1. But they have given that B is H of 2 is 2. So this one is wrong. So for this question, the correct answer is A, B and C. Since this is an MSQ multiple select question, so this will be the answer A, B and C. More than one correct answers are there. Any issues, any doubts, please let me know. If you are facing any concerns, if you are having any concerns, let me know. All fine. Moving to the next question. Good. For the periodic waveform shown in the figure, what frequency components are present in this trigonometric series expansion? Okay, so students, just by observation we can say that here this is negative half cycle. The area of negative half cycle is equal and opposite to that of the positive half cycle, and due to this, positive area and negative area cancel each other. DC component will be 0. DC component will be 0. Okay, now our signal is m of t. If you just check the even function, it is m of minus t is equal to m of t. So m of t is even function. Okay, then what if you delay this m of t by half period and then amplitude fold it, you will get the same signal m of t. See, half period, fold it, tapping this positive cycle. It means this is half wave symmetric also. Since it is even, it will be having only cosine terms, and it is half wave symmetric, so it will be having cosine, odd harmonics of cosine terms, odd harmonic cosine terms. Cosine terms with odd harmonics will be the answer. Cosine terms with odd harmonics will be the answer. Cosine terms with odd harmonics will be the answer. Okay. See this one. An input signal x of t is e raised to minus t u of t. Okay, is applied to an ideal low pass filter with frequency response characteristic given here. The value of omega c such that energy of the output is half to that of the input. So students, this one is a good question. X of t is e raised to minus t u of t. If it is e raised to minus at u of t, then its energy would be 1 upon 2a. So it is e raised to minus 1 t u of t, so its energy will be 1 by 2 joules. Okay. At the same time, I am taking the Fourier transform of this x of t, and I will get x of omega. x of omega will be 1 upon 1 plus j omega. 1 upon 1 plus j omega. Okay. So students, here we have h of omega. So this x of omega gets multiplied with h of omega so as to give us y of omega. What is y of omega? It is x of omega multiplied by h of omega. H of omega is range bound. So 1 upon 1 plus j omega into 1 will be 1 upon 1 plus j omega. Other value will be 0. But the range, the mod of omega less than omega c. And here it is mod of omega greater than omega c. I need to hide myself so that the entire screen should be visible to you. Now students, I need energy of this output. So energy of this output will be 1 by 2 pi minus omega c to plus omega c. Yes, y of omega magnitude square. Yes. Tushar bhai, Tushar Karmakar, Ashahid. Okay, students, minus omega c plus omega c. What is this y of omega magnitude? Yes, magnitude 1 upon under root 1 plus omega square. And when you square it, you will get 1 plus omega square. Root is cancelled. D omega. Just calculate this 1 by 2 pi. Anji, this will be tan inverse omega. And you need to put the limits from minus omega to plus omega c. Okay. So you will get 1 by 2 pi 2 tan inverse omega c. So 2 gets cancelled. And students, we have obtained the energy Ey. And they said that this Ey is half to that of the input energy. Input energy is 1 by 2 joules. So what is this Ey? Ey is given as 1 by 2 Ex. Okay. And what is the Ey you calculated? 1 by pi tan inverse omega c. And what is Ex? Ex is 1 by 2. Further divided by 2. तो tan inverse omega c will be क्या होगा pi upon 4. So what is omega c? Tan pi by 4, that is 1 radian per second. 1 radian per second. All set, students, getting the answers correctly? All of you getting the answers? Next, see this one. If x of t is a such signal such that x of t plus 4 equal to x of t. Students, x of t's Laplace is given as x of s. And we need to calculate integration 0 to 4 e raised to minus st x of t dt. Let me tell you that this particular equation is suggesting us that x of t is x of t is a semi-periodic signal. For semi-periodic signal, Laplace transform is x of s 1 upon 1 minus e to the power minus st integration 0 to capital T e raised to minus st x of t dt. So students, here this capital T is nothing but 4. Put this 4 here. So 1 minus e to the power minus 4 is, be careful, 0 to 4 e raised to minus st x of t dt. And you need to work out this integration. So this term will be cross multiplied here. So x of s into this bracket. So x of s into this bracket means option C will be the correct answer. X of s, it should be minus 4s in the power. So 1 minus e to the power minus 4s into x of s. This should be our answer. Option C is the correct answer. I hope you all have got this question. So students, out of these 8 marks, 5 questions I have taken from signals and system. Out of these 5 questions, how many questions have you got correct? What is your score? Do it. We are moving to the next. Now we'll observe the questions from engineering mathematics section. Now you will get a complete 13 marks questions package from engineering maths. Good, Bhavna, very good, very nice. Good, that's good. So students, here we have got a 3x3 matrix. Generally 3x3 matrix eigenvectors are not asked in GATE, but for you, I wish you to be prepared for this also, and that's why I have brought this question here. So this is a 3x3 matrix. You just calculate its eigenvalues. Arey bhai, you need to just write the characteristic equation. How to write the characteristic equation? How to write the characteristic equation? Subtract lambda from the diagonal values. Subtract lambda from the diagonal elements and remaining as it is. Subtract lambda from the diagonal elements as it is. So on solving this, you will be getting a cubic equation in terms of lambda, and the eigenvalues you will obtain as 0, 3 and 15. Okay, so I'm not going to solve this for you as of now. So 0, 3 and 15 are the eigenvalues. So they are asking for the largest eigenvalue. It means lambda equal to 15 is the largest eigenvalue. Lambda equal to 15 is the largest eigenvalue. Okay, so students, for lambda equal to 15, we are interested in what? Eigenvectors. So what you need to do? You need to write here 15 and construct equations. So 8 minus 15 will be minus 7 x1, then minus 6 x2 and 2 x3. Minus 6 x2 and 2 x3. Then what? Minus 6 x1, then 7 minus 8 will be 7 minus 15 will be minus 8 x2 and minus 4 x3. Okay, students, then 2 x1 minus 4 x2 3 minus 15 will be minus 12, x3 equal to 0. From these three equations, we will be solving the first two equations by cross multiplication method in order to find the eigenvector for eigenvalue 15. I'm keeping all the numerators to be positive and assuming the terms in cyclic order. When you write the elements for x1, just leave this, skip this x1, minus 6, minus 8, 2 and minus 4. And 2 and minus 4. After x2 in cyclic order, 2 and minus 4, then minus 7, minus 6. Then again minus 7, minus 6, and minus 6, minus 8. I need response from all of you. Anji, this is 24 plus 16, that will be 40. This is minus 12 and what? Minus 12 and then what? Minus 28. Minus 12 and minus 28 minus 40. This is 56 minus 36, that is 20. If you multiply, but that will be little bit more lengthy because 4 options multiplying, because it is 3 cross 3. Multiplying by 20, you will get 2 in the denominator, minus 2 and x3 as 1. So equal to k, and let us say k is equal to 1. So we have got the eigenvector as 2, minus 2 and 1. 2 minus 2 and 1. 2 minus 2, yes, option C is there. Option C is there. Okay. Yes, sir. Next. Now see here. We are having an n cross n matrix. A is an n cross n matrix. So order of the matrix is denoted by n equal to, yes, order of the matrix is n, in which all the elements of A are 1. Sare ke sare elements 1. All the elements are 1. When all the elements of a matrix are same, then its rank will be 1. All the elements are 1, so rank is 1. The number of linearly independent vectors is denoted by P. Number of linearly independent vectors is denoted by P, and this is actually n minus r. N minus r. So n minus 1. So number of linearly independent vectors are n minus 1. So students, solutions, number of linearly independent solutions will be P, that is n minus r. So answer will be n minus 1. Option C is the correct answer. Comfortable? Moving to the next. They have given you a function f of x. They have given you a function f of x where breakpoint is 0. So after 0, that is for greater than equal to 0, the value of the function is given as x plus 2, and before 0 it is given as 2 minus x. Okay, sir. So student, when you try to calculate, when you try to check its continuity, what you can do, just calculate the LHL, left hand limit. Left hand limit, when x is approaching 0, that will be 2. Now right hand limit, when x is approaching 0, this will be 2. So left hand limit is equal to right hand limit is equal to 2, and value of the function at x equal to 0 is also 2. So my function is continuous. Okay, but when I check the differentiability, I found that left hand derivative, yes, derivative of this quantity will be minus 1, and right hand derivative will be nothing but plus 1. Since left hand derivative is not equal to right hand derivative, so this function is not differentiable. So option A is the correct one. What? Function is continuous but not differentiable. This is the question which can be easily solved using the beta function concept. See here, students, if you are having an integration of this form 0 to pi by 2 sine raised to p theta cos raised to q theta d theta, then its answer will be 1 by 2 beta function of p plus 1 by 2 comma q plus 1 by 2. Now, for information, what is p and q here? P is 4 and q is 7. So students, this integration will be 1 by 2 beta function of p plus 1 by 2, 4 plus 1 by 2 comma q plus 1 by 2, 7 plus 1, 7 plus 1 is 8, 8 by 2 will be 4. So 1 by 2 beta m comma n, beta m comma n को क्या लिख सकते हैं? What you can write here? This is gamma m gamma n upon gamma m plus n. 5 by 2 plus 4, 13 by 2. Let us solve this. 1 by 2 gamma 5 by 2, keep it as it is. Gamma 4 is factorial 3, which is 6. Gamma 13 by 2, इसको कैसे solve करेंगे? Gamma 13 by 2, 7 by 2, 9 by 2, 7 by 2, 5 by 2, and further the remaining is also gamma 5 by 2. So this gamma 5 by 2 and 5 by 2 striked out. This 2 is also cancelled. Now how many 2's are remaining with you? 1, 2, 3. So 2 cube is 8. And in the denominator I am having 11 into 9 into 7 into 5. I request all of you to do the calculation. If you cancel this 6 by 3, you will get 3 2's are and 3. So 8 2's are 16, 33 into 30. This will be. I request all of you to do this calculation. So students, don't go away. After this, I will be solving some four more questions. Yes, Tushar, very good. And after me, you will be getting the questions from core subjects from favorite Saket Verma Sir. He will be taking up questions from EMFT and communication systems. See, this is a question from discrete probability distribution. The students, we know that summation for all the values of x, p of x, should be 1. This is the property of probability mass function. So when you add all this, what you will get? 3k plus 5, 3, 4, 4 plus 5, 9, 9 plus 7, 16, 16 plus 9, 25 plus 11, 36 plus 13, 49. So 49 times k equal to 1. So k will be obviously 1 by 49. So I am interested in this probability. Probability from for x equal to 3 to 6. So this will be 3 is not inclusive. 4 will be there, 5 will be there, and 6 will be there. Okay. 4, 5, 6. 4, 5, 6. 13 plus 11, 24 plus 9, 30. Students, 33 by 49 should be the answer. 33 by 49 should be our answer. Is that clear? Next. See this one. This is a question from vector calculus. This is a 2-mark question, numerical answer type question. Let us say this is our scalar function phi. So you need to calculate the directional derivative of this function. So first of all, you need to calculate its gradient. So phi is 1 by root 2 Anji x square y. I need answers from all of you. Then xy into y will be xy square. Okay. So when you calculate its gradient, Anji 1 by root 2 I del phi by del x. Just a moment. I del phi by del x plus j del phi by del y. Z component is not there, so no need to write it. So del phi, partial derivative of phi with respect to x. So students, before doing this, 1 by root 2 is out. I cap derivative of phi with respect to x. What you will write here? 2xy plus y square plus j cap derivative with respect to y. So x square plus 2xy. And yes, we need this at the point 1, 1. हमें चाहिए 1, 1 पर. So del phi at this point 1 by root 2. 2 plus 1, 3i. 1 plus 2, that will be 3j. Correct? Are you following? Just a moment, I'll show you the screen. Del phi is okay? Tushar? At 1 comma 1. At 1 comma 1. So this is your y-axis, this is x-axis. We have the point 1 comma 1. Okay. So what is its distance from the origin? It will be root 2. Its distance from the origin is root 2. And what is its angle? Its angle is given as pi by 4. Actually, they have given you the angle with y-axis, but obviously its angle with x-axis will also be pi by 4. So its coordinates, not coordinates, you say. R cos theta and R sin theta. Yes. So D vector will be, Hanji, I plus J. So what is D cap? Unit vector will be I plus J upon root 2. Okay, sir. Now what is this directional derivative? Directional derivative is del phi dot d cap. You know this? Del phi dot d cap. So 1 by root 2 3i plus 3j dot product with I plus j upon root 2. So root 2 into root 2 is 2 in the denominator. Then 3 and 3. 3 into 1, 3 into 1. That will be 6. 6 by 2 will be 3. I'm getting answer 3. Yes. So students, yes, Tushar Karmakar, y equal to f of x satisfies the boundary value problem d square plus 4 into y equal to cos 3. This is the differential equation. This is the differential equation. So I will be writing down the auxiliary equation. M square plus 4 equal to 0. So m will be 0 plus minus 2i. So CF will be C1 cos 2x plus C2 sin 2x. Very good, sir. This is the CF. After getting CF, what we can do? We will proceed for PI. Format for PI. What is the format for PI? 1 upon f of d into capital A. 1 upon d square plus 4 cos 3x. So this is case number 2. You need to replace d square by minus a square. So this a is 3. A is 3. A square will be 9 and minus a square will be minus 9. So minus 9 plus 4 cos 3x. So this is minus 1 by 5 cos 3x. So we have got the PI. We can write the complete solution now. Since complete solution will be CF plus PI. What is CF? CF क्या है भाई? CF is C1 cos 2x plus C2 sin 2x. What is PI? Cos 3x by 5. Okay. First initial condition is y of 0 equal to 2. 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 Okay. So y is 2 and x is 0. Y is 0 and x is, just a moment. Y is 2 and x is 0. So C1 cos 0 will be C1. C2 sin 0 will become vanish. Cos 0 is 1 by 5. What you are getting? Arey bacha, what you are getting? Y of 0 is 0, not 2. Y of 0 is 0. So C1 cos 0 will be C1. C2 sin 0 will be 0. Cos 0 is 1 by 5. So C1 is 1 by 5. C1 is 1 by 5. And one more condition is given. What is that? Another condition? Y of pi by 4 equal to 2. Are you following? Y of pi by 4 equal to 2. Put this in equation 1. Y is 2, x is pi by 4. C1 is, okay, cos 2 pi by 4, cos pi by 2, this will vanish. C2 is unknown. Sin 2 pi by 4 means sin pi by 2, that is 1. Cos 3 pi by 2 will be 0. So we have obtained C2 as 0. C2 आ गया हमारे पास 0. Students, finally, equation 1 is giving us particular solution. क्या है भाई particular solution? Y equal to C1. C1 is 1 by 5. Cos 2x by 5. C2 is 0. Not 0, yeah? C2 is 2. C2 is 2. C2 is 2. Okay. So 2 sin 2x minus cos 3x by 5. This is our particular solution. But what we want y of pi by 2. Y of pi by 2. Just put x equal to pi by 2. Cos 2 pi by 2 will be cos pi. Cos pi is minus 1 upon 5. Sin 2 pi by 2 will be sin pi, that is 0. Cos 3 pi by 2 will be 0. So y of pi by 2, yes my dear students, this will be minus 0.2. How many of you got this answer? कितने बच्चों का ये आंसर आ चुका है? Y of pi by 2 is minus 0.2, minus 0.2, minus 0.2. So we can move towards the next question. And students, this one is the last question, and after this question Saket Verma sir will be joining with questions from EMFT and communication systems. So let me check. Is ready or not? Sir is always ready. Let's check with sir. See here. The value of the integral, value of this integral, where C is the circle, mod z equal to 2. So students, if you say this is your function f of z, then by equating this to denominator, you will get to know what are the poles. The poles of f of z are z equal to 1. और इसका index क्या है? This is a repeated pole. Index is n plus 1 equal to 10. So what is n? N will be 9. So students, answer for this question will be 2 pi I and sum of all the residues. So we need to just calculate the residue of this pole. This pole is z equal to 1 is lying inside this circle, and that's why it will contribute to this integration. So residue means residue of this f of z at z equal to 1. It is 1 upon factorial n limit z tending to a nth derivative respect to z minus a to the power n plus 1 multiplied by the function f of z. N is 9, so 9 factorial, limit z tending to a is 1, 9th derivative with respect to z, and this is z minus 1 to the power 10 multiplied by f of z. F of z is z square plus z on z minus 1 to the 10. So students, for your kind information, this factor will get cancelled, and when you take the derivative of z square plus z, ninth derivative will be obviously 0. So when you supply this residue here as 0, your answer will be 0. Okay, friends. This was all about the questions from engineering maths, and now within a minute your favorite Saket Verma sir will be joining. Just give me 10 seconds connecting him. So that's all from my side, students. Thank you. Don't go away. Your favorite Saket Verma sir will be there. Let's welcome him with the hearts, and yes, try to be ready with the best set of questions from EMFT and communication system, and try to solve questions in good numbers. Thank you, students. Meet again. Bye bye.
Hello everyone, good evening. Good evening all of you. Yes, Bhavna. So I hope that my voice is clear. Yes. So voice and video are clear. So let's start the question from the electromagnetic theory. So I hope that you are having a good session with this GATE mock test with all of the faculties, and now I am coming with the core subjects like a communication system and electromagnetic theory. Yes. So I hope your preparations are good, Tushar and Bhavna. So let's begin the session with the first question. And I am taking very basic and moderate level questions so that you can have the very good command over the subjects with the formulas that you can recall. So let's begin with the first question. So this is question number 54 and this is a 1 mark question. So solve this question because this type of question has been previously also asked. So this is the variety of question that you will see in the GATE examination. So many student has already been joined. So the question is the electric field intensity at a distance of 10 km from an antenna having a directive gain of 3 dB and radiating a total power of 30 kilowatt. There are 4 options. So tell me which one of the following is correct. Which one of the following is correct? Okay, so one answer I have already got from all the other students also. I am expecting the answer. So come on guys. tell the answers quickly. So yes, let's see how to approach this question because the directive gain is given. So what is the formula for the directive gain? So the formula for directive gain is nothing but a 4 pi into u theta comma phi. In this way we can write divided by what? Radiated power. Okay, so divided by radiated power. Now, because we are looking for the electric field, okay, electric field intensity, so we have to convert this in the electric field intensity. So let's calculate this u theta comma phi is equal to directive gain. Let's represent it by GD and the power radiated divided by 4 pi. So this can be written as R square, radiation intensity can be written as R square into P average, and this is equal to GD into P radiated divided by 4 pi, and again if I put the value of P average, that will be written as E naught square upon 2 eta, which is for free space, so eta naught, and then we have GD into radiated power. This is radiated power divided by 4 pi. So from here we will have the value of electric field, which will be given as root over GD into P radiated, okay, and into 2 into eta naught divided by R square and 4 pi. So when we will substitute all the values, the values are gain is in dB, so we have to substitute in the normal value, absolute value. So 10 into 10 to the power 0.3. The radiated power is given as 30 kilowatts, so 30 into 10 to the power 3. So this is 2 into 120 pi, the free space impedance, and whole divided by R square. The distance given is 10 kilometers, so 10 into 10 to the power 3 whole square into 4 pi. So after solving all this, we are getting the electric field as 0.189 volt per meter. Absolutely right. So the correct answer is option B. Okay. So let's move into the next question. Question number 55. Quickly solve this question. Solve this question. This is a numerical answer type question. This is also 1 mark. Okay, so one answer I am getting. What is your answer, Bhavna? So as you can see that in the question, a radio link is given which is having the 50-watt transmitter connected to an antenna of 2 meter square effective aperture at 3 gigahertz. If the receiving antenna located at 10 kilometer line of sight distance from the transmitting antenna receives the power of 28 microwatt, assuming both the antenna to be lossless and matched the effective aperture area of the receiving antenna. So we know that when there is a wireless link and there are two antenna involved, then we use the Friis transmission formula. Okay, so we will use the Friis transmission formula, and this Friis transmission formula is P received is equal to AE for the transmitted, AE for the received signal, and the transmitted power whole divided by, in terms of effective aperture area, if you will write, then it is lambda square into, okay, so this is lambda square into r square. Okay, so this is what we have, and now we want to calculate the effective aperture area. So AER we want to calculate, then this AER will be PR into lambda. Lambda is nothing but a c square upon f square. Okay, so and then r square, and we have in the division which is AET into PT. So this is PR, which is the received power. So the received power is 28 microwatt. Velocity of light is 3 into 10 raised to power 8 whole square. The distance at which we want to calculate is 10 kilometer. So 10 into 10 raised to power 3 whole square, and then whole divided by f square. F is the frequency, which is 3 gigahertz. So 3 into 10 raised to power 9 whole square into transmitting antenna is having the effective aperture area, which is 2 meter square, and the transmitted power is 50 watt. So when we calculate it, how much we are getting? Yes, we are getting as 0.8 meter square. So the right answer is 0.8 meter square. So you can just note it down. If you have got the correct answer, then 1 marks is added in your total score up till now, whatever you have got. Okay, so this is the final answer for this question. Now solve this one. Okay, solve this one. In a free space, a plane wave with z less than 0, hi is equal to 40 cos 10 to the power 8t minus beta z ax cap ampere per meter is incident normally on a lossless medium. Epsilon is equal to 2 epsilon naught and mu equal to 5 mu naught in the region z greater than 0. The reflected wave is. So the magnetic field is given for z less than 0, and for z greater than 0 you have to calculate the electric field. This is a 2-mark question. So solve this one. What will be your right answer? Come on, quickly tell me what will be your right answer for this question. This is a 2-mark question. So one answer I have got. Okay. So I am getting different answers. Okay, so let's see whether A and B. I have got the two answers as A and B only. So let's see what is the right answer, either A or B. We want to calculate the reflected electric field. Okay, so let's first calculate what will be the expression of electric field incident wave. So incident electric field will be having ei naught, which is the peak value, and because there is a free space, so it will be lossless, and it is cos of 10 to the power 8t minus beta z and ax cap. Okay, so here we have ae cap to the direction of electric field. So what are the different values we want to calculate? We want to calculate the value of beta. So let's calculate the beta. Beta for free space is given by omega by c. This is the medium one for z less than 0, and this is 10 to the power 8 and c is 3 into 10 to the power 8. So beta 1 I am getting as 1 upon 3, okay, in the first medium. So this is 1 by 3. Now let's calculate the direction of electric field. The direction of electric field is calculated by AH cross AK of the incident electric field. So direction of magnetic field is AX, direction of propagation is positive Z. So we will get minus of AY. So we are getting minus AY direction. And what else? The EI naught. So EI naught will be calculated as eta naught into HI naught. So eta naught is 120 pi, and because it is already written in the terms of eta naught, okay, all the options in the form of eta naught, so we will write only 40 eta naught, that is the peak value, and it is in the ampere. So what is the expression of the incident electric field? So the incident electric field will have expression as 40 eta naught cos of 10 to the power 8t minus 1 by 3 z, and ae is minus ay. Okay, so this will be our answer. So this is the option A which you are thinking that it is our answer, but we want to calculate the reflected electric field. Okay, so if you want to calculate the reflected electric field, you have to calculate the reflection coefficient, and reflection coefficient is denoted by gamma. So the gamma for electric field is eta 2 minus eta 1 divided by eta 2 plus eta 1. So this is nothing but a root over epsilon r1 minus root over epsilon r2 divided by root over epsilon r1 plus root over epsilon r2 if it is lossless and non-magnetic. But okay, but because this is not a non-magnetic, so we cannot use this. So let's write eta 2. Eta 2 is 120 pi root over mu r and divided by epsilon r. So what is the mu r? It is 5 divided by epsilon r, which is 2. So eta 1 is free space, so it is 120 pi, and then we have 120 pi root over 5 by 2 plus 120 pi. So when we will solve it, we will get answer as, what is the reflection coefficient you are getting? So tell me quickly guys, what is the answer you are getting? So I am getting as 0.225. So 0.225 is the reflection coefficient. Now we want to write the expression of the reflected wave. So the expression of the reflected wave is ER naught peak value and the cos of 10 to the power 8t, and the reflected wave will go in the opposite direction, that is the negative z direction. So there will be plus sign, and then beta 1, which is for the first medium, z, and the direction of electric field will also be same, because we know that when we apply the formula eta 2 minus eta 1 divided by eta 2 plus eta 1, then the direction of electric field should be same. So er naught is nothing but this is er naught divided by ei naught. So er naught is equal to ei naught, which is 0.225 into ei naught. What is ei naught? It is 40 into eta naught, then cos of 10 to the power 8t plus 1 by 3 z, and the direction is minus ay. So when we will solve it, we will get minus 9 and naught, eta naught, and then cos of 10 to the power 8t plus z by 3 and ay. Okay, so the answer is option B. Yes, absolutely correct. Yes, Bhavna. Okay, so I have, you have got this. Is it clear? Do you have any doubt in this? Right. Now let's come into the next question, which is a 2-mark question again. Just outside a train compartment, the field strength of a radio wave is 0.5 volt per meter, and After that, assuming the compartment is to be closed of a metal box and having the conductivity 3 into 10 to the power 6, then thickness is 2 millimeter, and the frequency of the radio wave station is the 400 kilohertz, and the approximate field strength inside the compartment. So this is numerical answer type question. It is a 2-mark question. So as you can see that this is closed by the metal. That means metal is a conductor and it is coming from outside. That means free space. So this is also like moving from one medium to another medium. So the first medium is a free space where the electric field is maximum, which is 0.5 volt per meter. Now as the wave travels, okay, as the wave travels, it gets attenuated by a factor of e to the power minus alpha z. So what is the value of this alpha? Alpha is the attenuation constant, and because the second medium is a good conductor or conductor, so we can calculate its attenuation by the formula 1 root over pi f mu sigma. So when we will substitute the value of pi f and mu sigma, that is 400 into 10 raised to power 3, mu is 4 pi into 10 raised to power minus 7, and into sigma is 3 into 10 raised to power 6. Then what we are getting is, we are getting 2.176 into 10 raised to power 3 volt, Napier per meter. So this is Napier per meter. So this is what the value of alpha is. We want to calculate the 2 millimeter inside the conductor. That means compartment. So that is E naught, which is 2.176 into 10 to the power 3 e to the power minus alpha. Alpha is 2.176 into 10 raised to power 3 into z, which is 2 millimeters, or 2 into 10 raised to power minus 3. So when you will solve it, what you will get? Okay, sorry, one more thing that I have written mistakenly here. E naught we want to write down. So the value of E naught is, the value of E naught is 0.5. 0.5. So it is 0.5 into e to the power this one. Okay, so what is the value? Yes, what is the value you are getting, Bhavna? So it is coming as 6.44 millivolt per meter. So the answer will be 6.44 millivolt. So millivolt per meter. So our answer we will substitute here is 6.44. Got it? So because the first medium is the free space and the second medium is a compartment which is made up of the conductor and having the conductivity 3 into 10 to the power 6, so it is a good conductor. When you will calculate sigma upon omega epsilon, you will see that it is much greater than 1. Now coming to the next question. Inside a rectangular waveguide for a particular mode, the phase velocity is 3 times the group velocity at 5 gigahertz, then the cutoff frequency of the waveguide is. Okay, it is given that the phase velocity is 3 times the group velocity, then what will be the cutoff frequency? So we write this as a Vp divided by root over 1 minus what, write that, and this is also 1 minus Fc upon F whole square 3 times of Vp, and this is 1 minus Fc upon F whole square. Okay, now tell me what is the answer you are getting. Okay, so this Vp and Vp will get cancelled, and we will have 1 and 3, 1 minus Fc upon F whole square, right? So this will be 1 by 3, 1 minus 1 by 3 is 2 by 3. So Fc upon F is equal to root over 2 upon 3. Are you getting this? So we want to calculate the cutoff frequency, which will be operating frequency, which is 5 gigahertz multiplied with root over 2 by 3. So the answer will be in gigahertz, 5 into root over 2 by 3. So it is 4.08 gigahertz. So the cutoff frequency is 4.08 gigahertz and the operating frequency is 5 gigahertz. Okay. Fine. Let's move into the next question. For a distortionless line whose R is equal to 2 ohm per meter, G is equal to 2 into 10 to the power minus 4 Siemens per meter, and which of the following statement is or are correct? It is 2 mark and it is a MSQ question. So when you will see it is a distortionless, first thing that comes in our mind is R by L is equal to G by C. So if the R and G is given, so this is 2 and 2 upon, you can write R by G directly. So R by G, if you will write this R by G, and this is L by C, so this is 2 divided by 2 into 10 to the power minus 4. So this result is 10 to the power 4. Okay, so L by C is 10 to the power 4. Now what is the attenuation constant? Attenuation constant is given as alpha is equal to root over Rg. So when we will solve it, this is 4 into 10 to the power minus 4. So the answer is 2 into 10 to the power minus 2. So the correct answer is option A. Okay. The ratio of L by C is 10 to the power 4. So that is also correct. The characteristic impedance is given by root over L upon C. So this is 10 to the power 4 and this is 10 to the power 2. So the characteristic impedance is 10 to the power 2, not 200. Okay. and the characteristic impedance must be real because the distortionless transmission line is there. So this is a real quantity. So because of the distortionless transmission line, we can say that the characteristic impedance must be a real quantity. So 1, C and D, all the three options are correct. Okay. Now coming to the next question, guys, this is a communication system. Okay, so now we are starting the question from the communication system. So this is the first question in front of you. Using the map criteria, which of the following code 0 always as a 0? In which kind of channel you will have 0 as always 0? When you will read 0 as always 0? So because it is asking for the map criteria, what is the map criteria? If we write the map criteria over here, then we say that the probability of receiving 0 when 1 is transmitted multiplied with probability of 1 is greater of probability of receiving 1 when 0 is transmitted multiplied with probability of 0. Okay, then we take decision in favor of what? Okay, let me write in some different way. We write that if 0 is received, okay, if the 0 is received, then probability of receiving 0 when 0 is transmitted multiplied with probability of 0 must be greater than probability of receiving 0 when 1 is transmitted multiplied with probability of 1. Then we take decision in favor of, then we assume that 0 is choose 0 is received. Okay, so this is the condition of getting 0. So if this condition is satisfied, then 0 is transmitted. 0 is transmitted. Okay, now for the option A, if we will choose, this is 1 by 2, the probability of receiving 0 when 0 is transmitted, multiplied with probability of 0, it is 3 by 4. Similarly, when we will calculate this probability, this is 1 by 2 and 1 by 4. Which one is greater? Obviously, 3 by 8 is greater than this. So, we will choose the 0 is transmitted. So, channel code 0 always as 0. So, when we transmit 0, we will choose as 0. So, the correct answer is option A. Okay, now let's check option B. For option B, this is 3 by 8 and 1 by 8, and this is 2 by 8 and 5 by 8. So which one is greater? So the 10 by 8 is greater. So that means this probability is greater. So we will choose 1 is transmitted. Choose 1 is transmitted. So we want to choose as 0. So the option B cannot be the correct. Here again when we will select, this is 3 by 4, 1 by 4, and it is greater than 1 by 4 and 1 by 4. This is 1 by 4 and this is also 1 by 4. According to the criteria which I have written above, this is 3 by 4 and into 1 by 4 and 1 by 4 into 1 by 4. Which one is greater? 3 by 16 is greater. So again this answer is also correct. Here also we will choose 0. Here also we will choose 0 is transmitted. Okay. And now we have 1 by 7, 2 by 7. So this is 2 by 49 and it is 4 by and 5 by 7. So that means 20 upon 49. So obviously this is greater. So we will choose 1 is transmitted. Hence this is also not correct. So the correct answers are A and B. Correct answers are A and B. Now let's take another question, which is question number 61. So consider the passband signal x of t is equal to root 2 sinc t sine 101 pi t plus pi by 4. The complex envelope with respect to the reference signal is, okay, at fc is equal to 10 50 hertz 50 hertz. So how do we write the complex envelope? The complex envelope, any band pass signal, any band pass signal any bandpass signal can be represented in terms of complex envelope, which is x of t is equal to a real part of x complex envelope and e to the power j 2 pi reference frequency FCT. Okay, the reference frequency is 50 Hertz. So we have to represent the given signal in this form. So real part of root 2 sinc t, and we can write it as e to the power j 2 pi 50 plus 1 into pi t. Okay, and e to the power j pi by 4, and multiply with minus j. Okay, and also multiply with minus j. Real part of xce. Okay, so here you have to multiply with uh, minus j also. So root 2 sinc t will be there, and along with that this minus j. Let me write it again. Real part of minus j I am taking, and then root 2 sinc of t e to the power this. Okay, because why I have taken minus j? Because the sign can be written in the form of a real part if you multiply it with the minus j, right? Like if you write e to the power j theta, then the cos theta is the real part and sin theta is the imaginary part. So I am multiplying with the j. So if I multiply with the j, then it will be j cos theta minus sin theta, but we have the positive sin theta. So if I multiply it with by minus j, then minus j to the power j theta is minus sine minus j cos theta, and this will be plus. So the sine theta will be positive. So in this way I have taken minus j. So this is real part of root 2 sinc t and e to the power minus j pi by 2 and e to the power j pi by 4. Okay, uh, minus j can be written as minus j pi by 2 e to the power j pi by 4, and e to the power, here I have written this pi again, so this is only t. So e to the power 2 pi t will come, and e to the power j 2 pi 50 t will come. Okay, this is root 2 sinc t, and when we solve this, e to the power minus j pi by 4, and we have got e to the power j 2 pi 50 t. So which one will be the right answer here? This is 102. Okay, 100 and 0.5 I should write. This is not 1. This is not 1 actually. This is 0.5. So this is pi t. Okay, this is 0.5. So here we will be e to the power j pi t, e to the power j pi t. So when we will rearrange it again, real part of root 2 sinc t e to the power j in bracket pi t minus pi by 4 and e to the power j 2 pi 50 t. So this is called as complex envelope. Okay, according to the definition, this is called as complex envelope. So root 2 sinc t e to the power j pi t minus pi by 4 is option C. Okay, option C is the right answer. Very good. Now let's come into the next question, which is the question number 62. The block diagram of a segment of a FM transmitter consisting of a frequency multiplication and the mixer stages is shown in figure. The input is FM signal with the carrier frequency 13.5 megahertz and frequency deviation 8.5. The desired carrier frequency of FM output is 101 and the mixer is designed for the selective additive. Okay, it is chosen for the additive frequency. So we will only add the frequency because when we pass it through the mixer, it gets added. So and also subtracted. So what is the value of n in frequency deviation? And the frequency deviation at the output. Okay, it is easy actually. Frequency deviation at the output. So first of all, this carrier frequency we have got 101 and this is additive. So whatever frequency we will get over here, let's take f naught. So f naught plus 20. This is additive frequency. So f naught plus 20 is equal to 101. So from here you can say that this f naught is 101 minus 20, which is 81. 81 what megahertz. So this is 81. You have calculated 81. Now this is at input we have 13.5. So F output divided by F input is nothing but a 2n. So n is equal to F output which is 81. F input which is 13.5 multiplied with 2. Okay, 13.5 multiplied with 2. So n is 81 divided by 13.5 into 2. So we have got n is equal to what? 3. This is 27. 81 divided by 27 is 3. So n is 3. So these two options have eliminated. Now when you get n, so we know that the frequency deviation at the output and the frequency deviation at the input is equal to the multiplication factors. Multiplication of all the multiplication factors. So multiplication of all the multiplication factor is 2n. So if you want to calculate the output frequency deviation, so it would be input frequency deviation multiplied with 2n. N is 3, so 3 into 2 is 6. 6 into 8.5. So this is 6 into 8.5. So what is that? It is nothing but a 51 kilohertz. Okay, so the answer will be option D. Now coming to the next question. An audio signal of bandwidth 10 kilohertz is sampled at the rate of 24 kilohertz, quantized into 256 levels and encoded by M-array EM pulse, satisfying the Nyquist criteria with the roll-off factor of alpha is equal to 0.2. A 30 kilohertz bandwidth is available to transmit the data, the smallest acceptable value of M. The smallest acceptable value of M. Come on. Okay, so now the question is the smallest acceptable value of M for M array PAM. What is the bandwidth in case of raised cosine? For M array PAM, the bandwidth for raised cosine is RB 1 plus alpha divided by 2 and log base 2M. So the bandwidth is 30 and the bit rate is we have to calculate. Okay, so let's calculate the bit rate separately. So the bit rate is nothing but RB is equal to NFS. The number of bits the required will be 8. Fs will be 2 into Fm, which is 10. So this is 160 kbps. So the bit rate is 160 kbps. So this is 160 1 plus alpha, which is 0.2 divided by 2 into log base 2 m. So when we will solve it, log base 2m will be equal to 160 into 1.2 divided by 60. So this is equal to 160 into 1.2 into 1.2 divided by 60. So we have got as 3.2. Okay, so we have got as 3.2. So m is equal to 2 to the power 3.2. Okay, so it is nothing but a 8. The smallest acceptable value, because this value is coming as 9.18. So the smallest value we will choose that is acceptable is 8 level. Okay, that will be 8 level. Correct? FS is 24. Oh, sorry. Yes, Tushar, you are right. FS is 24. I haven't seen that. Okay, so according to that, I think answer will be different. So what is the answer you are getting, Tushar? I think still we get the same answer. So 24 into 8 is 192. So 192 kbps. So this is 192. Okay, so it is increasing. So 192, maybe the answer will be different. 192 into 1.2. 192 into 1.2 divided by 60. So we are getting 3.84. So answer is 14. So it is actually we should always take next higher integer. So it is coming around how much? 14.32. So it is close to 16. Yes, it is close to 16. We always have to take the next higher integer if possible, because it is very close to 16. So the answer will be now 16. Answer will be now 16. Because when we calculate it in number of bits, then the number of bits will be obviously taken as 4. The log base 2m is nothing but a number of bits. So number of bit will be always next higher integer. So that is 3.84 will be approximated to 4. So the number of bits required to represent each amplitude level is 4. Hence the number of levels or the number of amplitude level m will be 2 to the power 4. So that is 16. Yes. So that is 16. Yes, Tushar, correct. Now solve this one. Now solve this one. The power spectral density of random process x of t is shown below. If f naught is 0.5, then AC power contained in x of t. AC power means variance. Okay, AC power means variance. Variance is equal to mean square value minus mean whole square. So what is the value of mean square value? Mean square value means the area under the curve. So let's calculate the mean square value, which is nothing but the area under power spectral density. Okay, so area under power spectral density is area under our spectral density gives area. So this is 1 by 2. Base is 2 f naught into height, it is 1 plus the area of impulse plus the area of impulse, which is 1. So this is f naught plus 1, which is 1.5 watt. Okay, 1.5 watt will be the mean square value. And what is the mean? Mean is given by minus 0 minus to 0 plus 0 minus to 0 plus sx of f df, and from 0 minus to 0 plus this sx of f is sx of f is delta of f. Okay, this sx of f is delta of f. So this is delta of f df. So its area is 1. So the mean square value is 1. So the variance, that means AC power. So this AC power will be mean square value, which is 1.5, and mean whole square means 1. So we will get as 0.5. So 0.5 will be the AC power in watt. Okay, test, and we will include more conceptual mock test questions in the mock test in the next time, because this is the first time mock test we are taking, so we wanted to see the response of the students. So I think it is very nice to see that you guys have stick with the complete solution, which is from the 11 to 5. So almost we have taken 5 to 6 hours and marathon, and you guys have already involved in the mock test. So I want to suggest you that just appear in the different mock test. If you have prepared the subjects completely, all the subjects if you have prepared, then go for the mock test and revise your mistake. What are the mistakes you have done in the topic wise test and the subject wise test? Revise those mistakes, and accordingly you should go with the uh, next mock test, because you will not do that mistake. You don't want to do the same mistake which you have done in the past. So in the GATE exam also, you don't want to do the same mistake. Okay, so thank you for watching this session. We will meet in the next mock test, and also I am coming with the great crash course. So I am coming in the GATE AIMER'S series in the next week. So let's meet in that session. Okay, thank you, and all the very best to all of you. Thank you.